was incredible. An Ontario County nonprofit over horizon high-altitude balloons.
3, 2, 1, launch. Stand by for terminal count.
All right. Hello. I don't know what's going on with my intro today. Good morning, everybody. That was kind of weird. We had a little bit of it started like partway through the intro and then looped back. I don't know. Every once in a while that happens on my stream, but I got to figure out why the software decides to do that. But anyways, good morning, everybody. We're off to a great start today, but it's an exciting day. We got the Orbital Flight Test happening today for Boeing Starliner. This is part of the commercial crew program. It is an early morning here. Sorry, the intro thing kind of threw me off a little bit. But hello to everybody I see you in the chat here. I'm going to try to be a little bit subdued, but because the whole rest of my family is sleeping here, my house, which you can't really tell. Although, I forgot to change the SpaceX background. I got the SpaceX background behind me. I should have changed that. Oh well. Anyways, so good morning to everybody. I see everybody here in the chat there. Hello to Mikey over on the Facebook and Shivas and the Periscope channel. I also see a whole bunch of our regulars like Jade and Catherine and Gregorius and Sebi Time Waster over on the YouTube channel. So good morning to everybody. Thanks for joining us this early morning here. Don't know if it's early where you are, but it's early where I am. We're 6 o'clock in the morning here Eastern time, and we're getting ready to go. We got about 30 minutes until liftoff here. So now this is actually synced up with the United Launch Alliance clock that I have on the broadcast. So this should be pretty much right on the money. Gregorius says my mic cuts in and out for a few minutes there. Well, hopefully it resolves itself. I don't know if I can listen and talk at the same. Now it's out completely, it says. All right, we're off to a great start here with our live streaming. I'm not sure what's going on. You let me know in the comments if you can hear this all right. We're going to try to power through. If not, I don't know, we'll have to do some live troubleshooting. Now it's back. All right, everybody says we're good. So you get your comments you're seeing me about 30 seconds after I say it. So hopefully everything's all set and good to go. All right, it's an early morning. So anyways, NASA has already started their broadcast, so they are live. We'll probably switch over here. Actually, I can switch over while I'm talking so that you can at least see some of the visuals of what's happening this morning. Let's see. All right, so we'll switch it over here at least for a little while so you can see what's happening on the NASA. This is the NASA TV stream. United Launch Alliance also has a stream up themselves, but we're going to have the NASA TV stream up here that we'll watch a little bit. So liftoff is scheduled for 6:36 a.m. Eastern Time, and that's 1136 UTC. And this is an instantaneous launch window because they are rendezvousing with the International Space Station today. So this is going to be an instantaneous launch window, no opportunity for delays today. If they have to scrub for any reason, that'll be it for today. They'll try again tomorrow. They have another opportunity tomorrow. And then if they can't do it tomorrow, they have another opportunity Monday. Now this is particularly interesting for me only because this is not really a knock for United Launch Alliance, but a lot of United Launch Alliance launches have missed their opening of the window. A lot of times they still launch on the same day, but they seem to often have some sort of something that pushes it out a little bit. Now, maybe I'm being unfair to United Launch Alliance, but it just seems like when I'm watching, a regular Atlas V launch or a Delta IV launch or Delta IV Heavy, that more often than not, we have something that pushes it further back in the launch window that day, but they don't have that opportunity today. Today, we got to launch on time, instantaneous launch window. Now, I'm confident they can do it. United Launch Alliance is a pretty solid and reliable provider. Plus, a lot of the ground equipment here is brand new ground support equipment specifically for the commercial crew program. So I think we're in good shape. But I am kind of interested to see if anything comes up today that they're not going to be able to hit the instantaneous launch window. But so far, so good. We're doing all right at this point. So what's the plan of action for today, Lurch? Says Jonathan over on Facebook. So we're launching at 6:36 a.m. It's going to be about, let's see, I had my timeline up here somewhere. Where is my timeline? Well, since you're asking, pull the timeline up. Where is my timeline? But essentially, so we're launching, this is the commercial crew program, this is launching the Starliner. This is Boeing's capsule, CST-100 Starliner capsule. The CST-100 Starliner is very similar in size to the Crew Dragon capsule for SpaceX. So similar in size. It could, in terms of internal volume, it will have an anthropomorphic test dummy, or ATD, on board called Rosie. And that will be testing all the G-forces and things like that. And so Rosie will be on board as well today. And let's see, it will perform, it's going to do auto-docking maneuvers, not today, but to the International Space Station. So just like the SpaceX Crew Dragon capsule, this one will also auto-dock to the International Space Station. The big difference really between the Starliner and the Crew Dragon capsule, I guess there's a couple differences, but the big difference that I always think about for the two capsules is that the Starliner, when it comes back, will parachute and land on land, versus SpaceX parachutes and lands in the water. So when it comes back to Earth, and that will be sometime next week, I want to say, I forget what the exact date is, but I want to say it's like the 28th, I believe, that it comes back. Does that sound right to everybody? And Snoopy's on board. Yeah, I forgot about Snoopy. We also, Snoopy's little, that's basically our zero-G indicator for today, I believe. I was watching it as I was getting set up for my stream, so I didn't actually have the audio on, but I assume that's the zero-G indicator that they have up there today. But they're also carrying about 270 kilograms of cargo to the International Space Station. So it's not a completely empty capsule here. I mean, there's the anthropomorphic test dummy. I just like saying that anthropomorphic word. We've got the anthropomorphic test dummy on board. We've got Snoopy that's on board, which I'm sure they'll show at some point. And then we've got about 270 kilograms of cargo, mostly like food and supplies and things like that for the International Space Station. Figure you're sending a capsule up, might as well send some supplies along with it. So anyways, in addition to that, one of the things that's kind of interesting for today's flight is that this is not, so this vehicle, the Starliner capsule, is launching on top of an Atlas V rocket. And the flight trajectory today is not a typical Atlas V flight profile. So it's much shallower. So a lot of the flight profile typically for an Atlas V is a lot steeper in nature, but if you did that for a crew launch, if they had to abort for any reason, when they came back into the atmosphere, they'd either skip off the atmosphere and they would have a hard time coming back, or they'd come through the atmosphere so hard and they'd have way too high of a G-force on the crew. So they can't fly the typical Atlas V profile. They have to shallow that out and flatten it out a lot more than they would typically do. So they're going to run that trajectory today. And what's unique about this is that the second stage of this rocket today is using the Centaur upper stage. And that Centaur upper stage is going to have 2 of their engines on board, which is not typical for an Atlas V launch. They've done 2 Centaur engines before, like 150 times before. So that itself is not new, but they haven't done it in a while, and it's new for the Atlas V. They've done it on other Atlas launches. They've done it on, I can't think of, there's some previous launches that I'm drawing a blank on, but they've run the Centaur 2 engines before, but this is just going to be the first time for the Atlas V rocket. So they are, and that the 2-engine configuration is specifically there for that shallow profile, so that when they get up and they run that, they're going to use a ton of performance up on the first stage because of that shallow profile, and then they're going to need the 2 engines there for the extra thrust to try to get it into suborbital trajectory. Kind of confusing, but they're actually the Atlas V is going to drop this capsule off in a suborbital trajectory today, which is really weird. But the intent there is that if something were to go wrong at that point, it would come back after 25 minutes. So that after the Atlas V is done, they're going to use the remaining fuel from the launch abort system to actually circularize the orbits using the onboard thrusters for the Starliner capsule and service module. So that was the most efficient way to do this. So instead of carrying around all that abort fuel for the duration of the mission, they're going to go suborbital. Atlas V is going to drop it off, and the capsule and service module will continue on, and that will circularize with the remaining launch abort fuel that they have on board to actually get it into orbit. But it's a very shallow flight profile and suborbital trajectory that they're going to drop it off in, and then hopefully everything goes right and they can circularize. And then I believe they're going to dock with the International Space Station. I want to say, I got to find my timeline specifically for that. Let's see. Is the timeline up here? Nope, I don't have it here. I don't know what I did with my timeline. Had it up. If somebody has a link to the timeline, send it over to me so I can pull it up for everybody. But here, we can pull this up in the meantime, and we'll show this to y'all because we talked about this for a little while. Let's see. We want this screen right here. So this is what we're launching today. This is the expanded view of the Atlas V and the Starliner. So you've got the Starliner up top capsule. Obviously, this is intended to fly the first mission. The crewed flight test mission will have 3 crew members on board. So it has the capacity, just like the SpaceX Crew Dragon capsule, to fit up to 7 crew members, but they will probably never fly that for NASA. They're only scheduled to do 3 crew members. They may do 4 crew members at some point, but likely it's going to stay in that 3, right around that 3 to 4 range tops for NASA flights. But it has the capacity to fly up to 7. Or at least it has the room to fly up to 7, I should say. And you've got the launch vehicle adapter and the aeroskirt. Also, don't forget the service module, which they don't really specifically call out, but the service module is the portion that's connected to the bottom of the capsule there. Then you've got the aeroskirt. Now, the aeroskirt helps with stability. So when the 5-meter diameter of the Atlas V rocket, when they started doing profile tests and simulations on it, they noticed that with that lopsided capsule up on top of this rocket, it caused a whole bunch of aerodynamic instability. So they added the aeroskirt there. That's to help keep the rocket stable during flights with that kind of awkwardly shaped capsule on top of the relatively thin single stick of a Atlas V rocket. So then you've got that Centaur upper stage, the RL-10 engines, 2 of them on that Centaur upper stage. We've got the adapters then that go to the first stage, the Atlas V booster, and then we've got some solid rocket boosters and our RD-180 engines on the bottom of the Atlas V. Now, one thing I didn't specifically call out here is the emergency detection system. The emergency detection system is important for today only because that it is partially disabled for this particular flight. So the emergency detection system is what would trigger an abort scenario. If they had to do a launch abort or pad abort or anything like that, that's what the emergency detection system would do. But today, the emergency detection system will be doing the detecting and recording and all that kind of stuff, but they've disabled the actual abort triggers. So if something goes wrong on the pad or in flight, the capsule today will not perform a pad abort or in-flight abort. That portion of it is completely disabled. So if something goes wrong, this whole thing is going to go kaput. Let's hope that doesn't happen. It's not going to happen today. Not going to happen. But it is an important thing to note is that system is disabled so that they will not go into an abort scenario today. All right, let's back over here. Let's get this thing going, and let's see what we've got for comments here. How does the escape part work? So the escape motors are in the service module section of the of the Starliner capsule, and it's a pusher type system. So if an abort is triggered for some sort of anomaly that's detected on the pad, it will jettison the service module in the capsule instantly, pretty much instantly, light up those abort motors and take it away, just like we saw in the Boeing pad abort test or the in-flight abort test. But there was a pad abort test that they just recently did, only like, what was that, like a month and a half ago, that they did the pad abort test. And so it basically would launch up into the air, turn it around, drop the service module, parachute back down into the ocean. Now this is launching from Slick 37, is that right? Or is it 41? It might be 41. I think it's 41, actually, now that I think about it. Yeah, Slick 41. I was confused for a second. 37 is the Delta IV Heavy. This is Slick 41 today, but either way, this is on Cape Canaveral, Florida. So the point of that was that if we did have a pad abort, which we won't have today because it's disabled, but in the future, if there's a pad abort, they would land in the ocean. It'd be an ocean recovery, which is unique just because the Boeing Starliner capsule otherwise won't ever land in the ocean. If it's a successful mission, they're going to land on land with their parachutes. So let's see, what else did we see? No rocket tower abort. No, there's no tower system on this. So that would be a puller type system. Those big launch escape towers, those are puller type systems that would basically pull the capsule away from the rocket. This is a pusher system, which is on the service module that will push the capsule away from the rocket. And it's underneath the capsule as part of the service module. Oh, thank you. I think Gregorius just sent me the timeline. Thank you very much. There's no exact timeline, but there's a launch profile. Oh, okay. Well, I'll pull that up in the meantime. Is the booster going to die a watery death? Yes. So unlike SpaceX or anything like that, there is no opportunity for recovery on this first stage booster. So no excitement in that regards. This is going to basically jettison the first stage, and that's going to just come crashing down completely uncontrolled and be destroyed into a million pieces. Let's see. Yeah, and as Sebi Time Waster points out, until just a couple of years ago, that was completely normal. That's how everybody did it. So we're kind of spoiled now that we've had almost 50 SpaceX successful booster recoveries. We're just short of that, like 47 booster landings for SpaceX. So getting kind of spoiled, but pretty much everybody else still lets their boosters go crashing down into the water. Let's see, what else did I miss for comments? Oh, I don't know what the flags are while we were talking. I did see them packaging up the flags. I'm not sure what those are. We could probably turn on some of the time here, or the audio, I mean. Let's turn on some audio because we're down to under 14 minutes. We're still counting, and so we want to find out, we're going to try to find out what's happening, and let me read some comments here while they're chatting. Let's see what's going on here.
So Atlas will fly a little different flight than it's normally used to for us today, but 3.5 Gs is not uncomfortable for the crew. It's safe for them. Chris Ferguson has described it still kind of feels like a gorilla sitting on your chest, but that's...
It's a colorful description.
It's about normal for most launches.
And we want you to keep those questions coming. Thank you for all the great questions. Just remember to use the hashtag AskNASA. And we're standing by now, keeping an eye on Space Launch Complex 41, waiting for that crew access arm to begin its retraction. And when that happens, we will start to see the arm swing away. We'll see the white room slowly move away from Atlas. And that's going to be one of the last visible things that we'll see ahead of launch.
So up to this point, if there were crew on board, right before the crew access arm moves is where we'd configure the launch abort system. We'll see it slowly kind of move away, but it can actually swing back to the capsule in under 20 seconds for a less urgent emergency, like if there were a lightning storm coming and the crew had to get off the pad. But really, after that access arm goes away, if they need to get off, they're gonna leave on Starliner.
And Josh, you mentioned the abort system. I know that's not active on this flight. Can you help explain to people why?
Yeah, so ULA has this new emergency detection system on the top of their Centaur upper stage. It's basically 2 extra computers that are plugged into the rest of the rocket, and they are just really making sure that that system is going to work. We don't want to cause a premature abort since this is the first time that system's on Atlas. But that system is looking for what's called fast trigger aborts. So those are something that will happen so quickly that a human wouldn't be able to detect it.
And so we're going to see that, of course, is going to be activated. The next time Starliner flies, that next flight's going to be called the Crew Flight Test, and that will carry Boeing astronaut Chris Ferguson, NASA astronauts Mike Fink and Nicole Mann, and they will be next time sitting right on top of that Atlas V inside Starliner. But for today, of course, we've got Rosie inside, Snoopy inside, and that 600 pounds of NASA cargo. And we are a little over 11 minutes away from launch now. Again, just standing by because we want to make sure you get to see live that crew access arm swinging away. So we're just keeping an eye on things for you.
There you can see.
Yeah, now one of the things that I'm going to just jump in here and interrupt because I did want to point out a little bit of a difference here as well between SpaceX and Boeing. Now the SpaceX caught a lot of flack for this in some of the, I guess, traditional spaceflight media, or maybe some people that don't quite follow spaceflight that closely. But a big difference between just the launch procedure between Boeing and SpaceX is that Boeing fuels their rocket before the crew actually board the rocket. So the fueling actually happened hours and hours ago. We would actually be fueling the rocket for SpaceX at this point, like right now, they would still be fueling it. But for Boeing, the fueling happened hours ago, and this is a fully fueled rocket. And then they go into a planned hold, which was just before I went live. It's like a 4-hour hold, which is where that would be the crew ingress, where the crew would actually get into the capsule. That would have happened that would have ended just about a little over an hour ago. But they go into this planned 4-hour hold to do all the crew ingress. But all of that is done, and there goes there's the crew access arm starting to swing away nice and slowly, like they mentioned. So that's a big difference between the SpaceX and the Boeing rocket, because SpaceX loads the crew on board, and then while the rocket is completely empty, load the crew on board and then begin fueling the rocket. And the nice thing for SpaceX is that as they're fueling the rocket, the launch abort system is active the entire time. So if anything goes wrong, it can abort immediately, even during fueling. This is kind of the traditional way, which was thought to be safer generally, which was to load all the fuel, make sure the vehicle is stable, and then put the crew on board. And so that's what Boeing is, or I should say United Launch Alliance is doing with the Atlas V rocket. So I did just want to point that out here, and we can see now the crew access arm retracting, which is kind of nice to see. Nice and slow, but as they mentioned on the broadcast, it can swing back in 20 seconds if there's some sort of emergency that they need.
Again, about
Hopefully
9
we never
minutes
see
away
that.
from launch.
It's getting exciting though. We're under 10 minutes here now.
All right, and there you see the crew access arm just finishing its swing away from the Atlas V rocket and Starliner, and we want to go over to Dylan Rice in the ASOC for a status update. Dylan?
Tell
Hey,
us,
Marie.
Dylan.
So we're continuing to have a very clean countdown here. We're just a few moments away now from Chief Launch Conductor Doug Lebo conducting that terminal count status check poll, which will take us into our final countdown to launch. That terminal count status check poll is the final check from each operators associated with the ground systems, the launch vehicle, the spacecraft, and the Eastern Range to ensure that all systems are ready to go for us to proceed into a terminal count and get the rocket launched. So we're just about a minute away from that now. And I can tell you that we've executed this countdown many times for a variety of different missions, but the countdown today feels quite a bit different than what we've normally done. The excitement here is just unbelievable, and we are very, 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 very excited to see this mission go and go on time, especially with such a clean countdown like we've had today. So we're really looking forward to this. The team has not been talking any issues at all on any of the other nets that I've been listening to. So when that terminal count status check starts, we're expecting to hear goes across the board. So I think we'll stand by here and listen for Chief Launch Conductor Doug Lebo to get that poll started here in about 20 seconds, I think.
Yeah, So this has got to be a little bit stressful for the United Launch Alliance and Boeing team, especially knowing that, you know, this is intended for commercial crew eventually. And so this is basically the precursor. This is the last, pretty much the last flight that Boeing and United Launch Alliance will do before they load crew onto that capsule. And so they really want to make sure that everything goes perfectly here, because this is...
Status check to proceed with terminal count. Atlas systems, propulsion.
This is their
go.
demo here.
Hydraulics, go. Pneumatics, go. LO2, go. Water, go. Centaur systems, propulsion, go. Pneumatics, go. LO2, go. LH2, go. Has gas, go. Electrical systems, airborne, go. Ground, go. Facility, go. RFFTS, go. Flight control, go. GCQ, go. Op support, go. Com, go. Umbilicals, go. Arm control, go. ECS, go. Redline monitor, go. Quality, go. Op safety manager, go. ULA safety officer, go. Vehicle system engineer, go. Anomaly chief, go. Range coordinator, clear to proceed. Flight director,
Flight is go.
launch director,
LD is go, and LC, you have permission to launch.
proceeding with the count. ALC, verify T0 is set for 11:36:43 Zulu.
Verified.
So everybody's go for launch. That's
Well,
a good sign.
Josh, Marie, you heard it. We are go for launch, right on time.
All right, thanks, Dylan. Yeah, we heard some cheers behind us over at the press site when we heard that you have permission to launch. And I know they're feeling good about that over in the Boeing Mission Control Center. Tori's standing by over there, and we're hearing she's got a very special guest to say hello.
Thanks, Marie. Yes, I do have a very special guest here today. I have Chris Ferguson, first Boeing astronaut and former space shuttle commander. So, Chris, you heard the poll. You were here, you know, being part of some of the other polls this morning. Can you tell us how it's going?
Well, every launch has its exciting moments. We had a few earlier with a minor issue that came up, but we've developed all the necessary rationale to go flying. And you just listened to the poll. Basically, everybody is in line and in agreement that we're in a good configuration to go fly. So it was a little close, but hey, we're going to be off to the races here in a few short minutes.
I know this is a really exciting time, right? Less than 5 minutes here until launch. So, you know, it's funny. When
Anybody know what the issue was earlier? I didn't hear of an issue.
About 8 years now. So
I want to know what this issue was earlier now that almost prevented launch today.
And to CFT, can you tell us a little bit more about your role within the Starliner program?
I joined the program about, like you said, 8 years ago, shortly after the space shuttle program ended, and it's been wonderful to be a part of the team. It's been wonderful to have some influence in the design, and now, you know, it's almost surreal. There it is out on the pad. You know, the labor of the last 8.5 years is sort of coming to, you know, it's game day, right? The big test is, and mind you, you know, our big game, right, for the spacecraft actually begins when the launch vehicle releases us 11 minutes from now. So we've got a lot of work to do, even though this is the exciting part that everybody enjoys watching the launch. Our big test really begins when the launch vehicle sort of releases us, and we have to go, you know, perform all the necessary demonstrations to get ready to dock to the International Space Station tomorrow. So we've got a busy 24 hours.
Yeah, Chris, that is really exciting, right? It's busy, but I know the teams here are up for the challenge.
Absolutely.
All right, Josh, Marie, thanks for coming to us. Back to you.
Yeah, so I want to know, he talked about some sort of issue earlier that almost scrubbed the launch for today. He said they had a little bit of excitement. I don't think it was weather. It sounds, because weather is relatively good for today. It sounded like maybe there was some sort of vehicle issue or ground equipment issue. Everybody's saying no clue what the issue is, but I don't know. That got me a little bit nervous. The way he talked about it, it sounded like they were. What he had said, it didn't really sound like they resolved the issue. It sounded like they decided to work through it. Like they were going to be like, all right, continue. I don't know. That was just my perception of what he said. It's like, well, we had a little bit of excitement. We got an issue, but we evaluated and we decided to proceed. Like it didn't really say like, well, we fixed the problem. So anyways, now I really want to know what the issue was. So if anybody can find that, do let me know, because I'm really curious. But we're 2.5 minutes away from launch, so hopefully they got the issue resolved, because we're coming up and we're ready to fly here. Turn this back up here. This is exciting.
If you're just joining us, we're approaching 2 minutes from the very first flight of Boeing CST-100 Starliner to the International Space Station.
2 minutes.
159.
Vehicle internal.
155.
Launch sequencer start.
150. Securing Centaur LH2.
Securing Centaur LO2.
The rocket is now on internal power as well. Both Atlas and Centaur
140.
tanks.
Launch enabled.
137.
FCS armed.
That was the flight termination software. If Atlas veers off course.
Yep, so they're still using flight termination if something happens, but no
120.
abort today. The abort system is there. It's just not enabled.
SCS count started. EDS ascent mode.
That was that emergency detection system, EDS.
Yep, so they'll be doing the detecting. They're just not going to actually, not going to trigger an abort.
T-minus 1 minute.
Rock, report range status.
Range green. 54.
VLP started.
Oh no! What happened to my... Oh, there we go. My screen froze here. We're still good. We're still good. I'm just going to try not to touch
30
my computer.
seconds.
T-minus 25 seconds.
Status check.
Go Atlas. Go Centaur.
Go Starliner.
Go Starliner.
Here we go. Ready to go.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and liftoff. The rise of Starliner and a new era in human
there we go.
spaceflight.
Clear the tower. Now 10 seconds into flight. Vehicle's begun the pitch over program. Body rate responses look good. Now 15 seconds in. VU's gone to closed loop control. RD-180 looks good at full thrust. Seeing good chamber pressure on both SRBs. Now 26 seconds into flight. RD-180 now throttling down to partial thrust as expected. Engine response looks good. Now 38 seconds in. RD-180 engine operating parameters continue to look good. Vehicle is now passing through max Q, maximum dynamic pressure. Chamber pressures on both SRBs continue to look good. RD-180 engine operating parameters also continue to look good. Now passing 1 minute into flight. And Mach 1, Atlas 5 is now supersonic. And vehicle now throttling up. Engine response looks good. Continue to see good chamber pressure on both SRBs. 1 minute, 20 seconds into flight. Body rate responses on the vehicle look good. 1 minute, 30 seconds in, standing by for SRB burnout. And we have burnout on both solid rocket boosters. Atlas will hold on to the SRBs for an additional 48 seconds prior to jettison. RD-180 has gone back up
That's
to
kind
full
of
thrust
interesting.
as expected. Engine response looks good. 1 minute, 50 seconds in. Atlas is now 17 miles in altitude, 11.5 miles downrange distance, traveling at 2,300 miles per hour. Now passing 2 minutes into flight. RD-180 engine operating parameters continue to look good at full thrust.
Wonder what the reason is for that they're going to hold on to the SRBs. Maybe
And at
for
2 minutes,
stability or
11
something?
seconds into flight, the Atlas rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of 2,800 pounds per second. And we've seen good
there go
indication
the
of jettison
SRBs.
of both solid rocket boosters. Vehicle's gone to closed loop guidance.
Now just under 2 minutes remaining in the booster phase of flight. 2 minutes, 35 seconds into flight. RD-180 continues to perform well. Engine's now throttling down slightly. Engine response looks good. And Atlas V is now traveling at over 5 times the speed of sound. Centaur reaction control system is now pressurizing to flight levels. System response looks good.
So far, so good. I kind of
3 minutes, 10 seconds into flight. Atlas V is now 38 miles in altitude, 80 miles downrange distance, traveling at 5,800 miles per hour.
I don't want to talk over this guy because I'm interested to hear what he has to say.
RD-180 engine operating parameters continue to look good. Now 1 minute remaining until engine cutoff. Body rate responses continue to look good throughout the booster phase of flight. And RD-180 is now throttling to maintain a constant 3.5 G acceleration limit. Engine responses will all look good.
Should be coming up on cutoff here
3
shortly.
minutes, 55 seconds into flight. And Centaur's begun the boost phase chill down sequence.
Bet we get some cool
20 seconds to BECO.
Get some
RD-180
cool photos
continuing
of
to
that.
look good as it throttles to maintain that constant 3.5 G acceleration limit.
That exhaust trail. It's hard to
Atlas
see
P
how
has gone
far
to
away
open
that
loop in
actually is.
preparation for BECO. And standing by for BECO.
BECO would be booster engine cutoff. So,
And we have
right there.
BECO booster engine cutoff, standing by for stage separation. And we have good indication
Looks
of
good.
stage separation. We have
Hard to-
pre-start on the RL-10, standing by for ignition. We have ignition and full thrust on both RL-10 engines. Chamber pressures look good on both engines.
Yeah, I bet you get some cool photos of that. You can see that exhaust cloud up there. It'd be cool
We
to
have
see.
confirmation of ascent cover jettison on Starliner.
Aeroskirt jettison.
Got rid of the aero skirt.
And we have good indication of aeroskirt jettison.
Wish we had some better
Centaur now
camera angles
resuming
here.
active attitude control after successful aeroskirt jettison.
I mean, not that I don't want to see
Chamber
the flight
pressures
team,
on
but
both RL-10 engines continue to look good.
This
see
was a
on
very
board.
critical piece of the mission here. Staging is always a very dynamic piece of flight.
Now passing 5 minutes, 30 seconds into flight.
That's a big team there. I guess we don't have a...
And the Centaur RCS system is beginning the initial thruster firings for system thermal conditioning. System response looks good.
Now, once again, Centaur will continue
Engine propellant utilization
burning
system
for about another 5 minutes.
So this is a very long... I don't know, the interesting thing
now
here...
passing 6 minutes into flight.
This is a very long... I'm going to turn him down a little bit, but this is a very long boost phase. Especially considering that they're only going
95 miles
suborbital.
altitude, 570 miles downrange distance, traveling at 12,000 miles an hour.
I want to see what's going on. I know, me too, Catherine. I want to see what's going on. I'm going to try. I was reluctant to do this before launch, but
Those dual RL-10 engines.
I'm going to try to get rid of this my countdown clock that's up there in the corner.
A little bit of the booster flying
But
ladder
I was
to
afraid to do this
lower thrust again to maintain that 3.5
during launch because I didn't want my software to crash. Let's see what happens.
for the Dual-Engine Centaur.
Okay, good. Didn't crash.
Starliner and Centaur continue to head to orbit.
Throughout the Centaur burn,
all
chamber
right,
pressures
let's
have
back
remained
up a
very
little bit.
stable.
Yeah, everybody's... And we get
Just
a little
under
bit...
5 minutes now remaining in the burn.
It's really hard to talk while this guy's in my ear, but we get a little bit spoiled with the SpaceX streams. You know, we got those beautiful camera angles and the beautiful animation of where it is. I mean, right now we're kind of just looking at the team, which is...
And
not
Centaur
really,
is now 102 miles in altitude, 800 miles downrange distance, traveling at 12,700 miles per hour.
so that's not really... I want to see what's going on, and it's hard. I can't actually talk... I can't talk over the person because there's nothing
And
to
the
see
Centaur
what's going
propellant
on.
utilization system
If I talk over him, then I don't know what's happening. So I guess we're gonna watch and listen in to this for a little while, at least during the boost
That
phase.
means
maybe
Atlas is flying almost exactly where it needs to be.
Periodic thruster firings as expected.
So Shivas was asking, the rocket maintains Mach 2.7 speed. No, I think what they were saying is it maintains, I don't know if...
Now passing 8 minutes into flight.
I don't know if they said 2.7. I didn't actually hear it, but I know at one point they said 3.5 Gs maintain a constant acceleration. It's not the actual speed, but they maintain a constant acceleration, mostly for astronaut comfort, also to make sure the vehicle doesn't break apart, but it's basically how quickly they're building up speed, the delta V, or change in velocity. So it's just the acceleration that maintains constant, not the actual speed. The speed is still going up, but the rate at which that speed is going up is constant. You don't want that to go too high. That's where you get your G-forces. If you start building speed too fast, it'd be very uncomfortable or even dangerous for the astronauts. So yeah, it's just a constant acceleration there that they were referring to. Let's see.
And now coming up on 9 minutes into flight, Centaur is 101 miles in altitude, 1,200 miles downrange distance, traveling at 14,300 miles per hour.
Now the two control rooms you are looking at on the left, that is ULA's Denver Operations Control Center. They are a backup control room for the control room on the right, which is the actual Atlas Spaceflight Operations Center. They were the ones who launched the rocket about 9.5 minutes ago.
Now close to bottle temperatures.
Yeah, so Catherine mentioned that
you can see,
she
everyone
thought it would be nice for NASA to have camera access. They may actually have access. They may just not be showing it to us, whether they have cameras on. We did see a camera on board, but they may just not be showing us the onboard cameras. But even without the onboard cameras, NASA is very accustomed to working off of the data that's there. They don't really need to see what's happening. I mean, they have enough sensors and data streams coming back that they have tons of information, and they're very, both NASA and United Launch Alliance are very accustomed to operating their flights just based on the data that they're looking at. They don't necessarily have to see a picture of it to know what's happening with the vehicle.
Bottles. Telemetry quality has been good throughout this burn, only seeing very brief minor dropouts.
So Sebi Time Waster mentioned about the actual control room, the one on the right, being so much smaller than the backup control room. I imagine, I don't know this for sure because I've never actually seen this control room in person, but I imagine either that control room is bigger than they're showing on camera, or their support engineers are in another room. So they may have two control rooms, but I bet this control room is just bigger than what they're actually picturing here, but I don't know that for sure, because it is weird that the backup is so much larger. But a lot of times the way those control rooms work is they put basically the main team in one control room. This is how like the Apollo launches worked and the space shuttle. The main control team was in one room. It was a single person from each kind of subsystem was in one control room, but they would have another control room, sometimes two control rooms that would have tons of people from each team that were basically the support services for the main controller. And so they may have an entirely separate room for that at the main control center there, the one that's pictured on the right.
Free fly for the first time in orbit.
Standing by for main engine cutoff.
Well, we're coming up on main engine cutoff. This would be basically the end of the Atlas V portion of the mission.
And we have MECO, main engine cutoff.
It is.
Body rate responses have remained very stable. Now passing 12 minutes into flight.
Now Starliner will stay attached to Centaur again until about 15 minutes, expected to separate at 14 minutes and 58 seconds after liftoff. And that will be the first time Starliner free flies in orbit. And at that point, Richard Jones and his team in Houston will have full control over the vehicle. and they will set it up for an orbital insertion burn that will take place 16 minutes after separation.
Yeah, so a lot of engine burning happening today, as I mentioned a little bit earlier. So we've had main engine cut off. That's the end of the Atlas V portion. Well, the Atlas V still has to separate from the Starliner capsule, but essentially the most of the work.
Approximately 2 minutes now remaining until OFT capsule separation.
And so we're waiting for separation, but other than that, the Atlas V is done with its job, but it's
Body
still
rate
suborbital.
responses continue to look very stable throughout this coast.
If they do nothing, it will come back and land. It'll come back to Earth in about
So you're
T
looking
plus
at the
25
Boeing
minutes.
Mission Control Center there. At this point, they have transitioned to a mission support room. The people you're seeing sitting on console designed, tested, and built Starliner. They are the experts on the systems. So if flight controllers need any help, they will be the ones answering the call.
Now passing 13 minutes,
Yeah, so
30
that's
seconds into flight.
That's that backup support room that I was talking
Well, in
about.
just
the
over
other
a minute, we're expecting to hear that Starliner has separated from the vehicle.
This looks like NASA's control center. Is United Launch
And
Alliance,
about 1 minute
backup
now
center.
remaining until OFT separation.
Just waiting for separation here. Once we get separation and things calm down a little bit, we'll chat about a couple things that we saw here. I'm just trying.
Body rates in the roll, pitch, and yaw direction, all very close to null.
It's so hard to. Like, I don't want to talk. Like I said, I don't want to talk over them because you don't know what's going on because we have no visuals. So the only way to know what's happening is
And
to
about
listen.
30 seconds away from spacecraft set.
So I don't want to talk over the guy. And then we still have, so I started saying this, but we've got separation coming up for the actual capsule, and then they have to do a whole nother burn with the Starliner's onboard orbital thrusters. And that's using the launch abort propellant that's in the service module. They're going to use that up to actually circularize.
Indication of separation of the OFT capsule.
So we got separation.
There it is.
These are good.
ULA has successfully completed their piece of the mission. Starliner is free flying for the first time in space. From here, the Johnson Space Center mission controllers will be flying Starliner. We will hear reports exclusively from there.
So there, at that point, United Launch Alliance team is very happy now because they get to celebrate a little bit. They did their jobs. Atlas V is done, got it into, not orbit, like I said, it's suborbital, but the Starliner capsule itself still has to do a little bit of work. So now it's up to Boeing and the Starliner team to actually get this into orbit. But United Launch Alliance has cause for celebration here because their portion of the mission seems to have gone completely successful, as far as I can tell here.
Systems that were needed for powered flight but are not necessary now that Starliner is in orbit. While some are turned off, others will be turned on, such as the thruster housings that will be used to maneuver Starliner in space, and the solar arrays. The thrusters will steer Starliner through orbit.
What's Ilias said that was a long hug. That was a very long hug, wasn't it? All right, so let's see.
Left Starliner in an elliptical trajectory that would make it easy for the spacecraft and, more importantly, its future crews to come back to Earth at this point if there were a problem. But that means it's all on Starliner to make it the rest of the way into a stable orbit and on track for the space station docking. This is where Starliner's orbital maneuvering and attitude control engines come into play. Those 20 engines can provide each up to 1,400 pounds of thrust, which is more than enough to neatly heave Starliner that last little bit into orbit. They'll fire for about 40 seconds, setting Starliner on the right path, not only for docking with the space station, but also a series of demonstrations that Starliner will perform before docking.
And those demonstrations will prove that Starliner is ready to safely dock with the space station. They actually began on the launch pad when we performed a check to make sure that Starliner's GPS and navigation systems agreed that it was indeed on the launch pad. After the upcoming orbital insertion burns, the demonstrations will continue so that ground controllers can ensure that the spacecraft systems are functioning correctly. When these first demos are complete, Starliner will resume its path to the International Space Station, and our systems here are telling us that these early steps are complete, and the Starliner systems are doing exactly what they are supposed to do.
We still have a few minutes before that orbital insertion burn, about 13 minutes until it takes place. So let's go back to Florida, where Josh and Marie have watched a spectacular morning liftoff.
Okay, so while they're chatting it up there, I'll let them talk about it. The Starliner is going to get circularized here, but the Atlas V is actually still going to do a little bit of work to actually deorbit, or not necessarily deorbit. It's suborbital, so it's going to deorbit itself. But they do have to. They're going to purge kind of the propellants and things like that. So the United Launch Alliance crew has a little bit of work that they're still going to do at this point. But for the most part, their portion of the mission is over, and that Centaur engine will splash down about an hour after launch. So it's going to be up there for a little while still. But I did find, and all of this is coming from my mission timeline here that I was looking for earlier that I could not find. So we're going to pull this up here a little bit just to show you what we've already gone through. So all of this stuff is done at this point here, but this is kind of the mission booklet here. We looked at the expanded view of the rocket here today. United Launch Alliance is always nice to point out where all their things are assembled and put together. So you've got things like the solid rocket boosters being fabricated in California. You've got design and engineering for United Launch Alliance, which is in Denver, Colorado. You've got the booster adapters and the Centaur adapters being built in Texas. The main booster fabrication and final assembly. Same thing with the Centaur tank fabrication and final assembly. That's all happening in Alabama. Then we got the engine fabrication happening in Florida for the RL-10s, and then the RD-180s. Those are a Russian engine. Those are being built still in Russia, which United Launch Alliance has had to answer some questions to like U.S. Congress and things like that because they're basically the Atlas V is dependent on the Russians to build the RD-180 engine for them to be able to launch their rockets. So unlike SpaceX, which is building all of their stuff here in the United States, the RD-180 is a fantastic engine, but it is still built in Russia. So we do have this other country that they have to rely on to be able to get those engines. Now, from what I understand, they have a huge stock of them, so there's no immediate issue. If all of a sudden they decided to stop supplying engines, but eventually that could be a problem, especially because that first stage booster is not recoverable. So every time they launch this rocket, those engines are disposed of. But anyways, so we've had, and then we had the entire timeline. This is what I was looking for earlier, is this little timeline here, because I was trying to figure out what the mission timeline there was. But Starliner separation happened just prior to 15 minutes, and then the Atlas V, or the Centaur actually, is going to go through a little bit of final preparation before it re-enters the atmosphere and splashes down out in the Indian Ocean. But you can kind of see it's a little bit small. I wonder if I can zoom in on this here. Yeah, we can zoom in. There's the map here for trajectory of what we're looking at today, which is basically following the International Space Station's same inclination and trajectory there as well. And so that splashdown, that's number 12 on the list there. That's where the Centaur engine is going to splash down. So there we go. That was the timeline that I was looking for earlier. All right, we'll switch back over here. We can get rid of this, move that out of the way. And then when I wanted to see, I was looking for I was looking for rendezvous time for space station docking, because I think that's happening tomorrow, but I don't know what time that's scheduled for. Anybody know what time that's scheduled for? Let's see if we can find that real quick. Yeah, I can't. Nope, right, nope. Okay, well, I don't have it readily accessible, but if anybody knows the actual time of rendezvous and docking, I believe that's happening tomorrow. They did mention that they're going to have some demonstrations of the flight vehicle. Those demonstrations are basically it's the same thing that SpaceX went to as they rendezvoused and docked with the International Space Station. They have to demonstrate that the vehicle can hit and hold at certain points, which is, if you've ever played Kerbal Space Program, not an easy thing to do. I mean, it's probably relatively routine for the people in the aerospace industry that are doing this on a regular basis, but for the average person, that's some pretty complicated stuff going on where they're actually holding at a certain point. So the Starliner will do a series of demonstrations to make sure that they basically have full control of the vehicle and that it's doing exactly what it's supposed to do as it approaches the International Space Station before it gets cleared to actually do the docking. So they'll do the same thing that SpaceX did. They'll have these hold points. They'll do back-offs, which are meant to simulate some sort of problem where they tell the vehicle to, basically back it up, get away from the space station a little bit. And then they'll eventually come back, hit their hold points, and then do the final docking. And all of that, I believe is happening tomorrow. I still can't find the specific time when that's going to happen. But it's definitely not today. That's for sure. All right, let's see what we missed for comments here. Why are we buying rockets from Russia when they well, the Atlas V, the Russians have been very good at building rocket engines, and the RD-180 is a great engine. And so, from a cost standpoint for United Launch Alliance, it makes sense. I mean, it's already developed. It's a great engine. They can just buy them directly from Russia. No problem. Problem really comes into, if we ever get into a little bit of a disagreement with Russia, we're still reliant on them to supply those. So, yeah, I mean, I see that as a minor issue. Hopefully that never happens, but something to consider for sure. Let's see. Did we used to make them ourselves? No, the RD-180 engine has always been made by that's a Russian-developed engine that has always been made by Russia. It's not something that we made and then we outsourced to Russia. Like that was a Russian engine that United Launch Alliance, when they were looking for an engine to put on their rockets, they looked for the best option, and that's what they decided. They are changing that for their upcoming Vulcan rocket, which is the newer rocket that they're trying to develop. They're no longer going to use any of the Russian engines. They're actually going to use Blue Origin's BE-4 engine. So they are bringing that back into the United States here. They'll be using the BE-4 on their Vulcan rocket, but the Atlas rocket has been going for a very long time here now. It really doesn't make sense to change the design of that at this point. And they have enough, from what I understand, they have enough engines to meet their contract, their commercial crew contract as it stands right now. So it really wouldn't be an issue for any of the scheduled commercial crew flights because they have enough engines to meet all of those. So it's not like if they were cut off from getting any more engines, they could still satisfy their contract. They might not get another contract, but they could satisfy their existing contract. So that would be that's not an immediate problem here. Let's see. Love the images of the backroom crew. Great to see. Yeah, it's always nice to see. It's nice to see the expressions on people's faces as they're trying to manage this flight, and the little bit of stress that you can just see through their eyes on, like, is everything going to go right? It is always kind of nice to see. Although I do like to see some of those camera angles to just kind of know what's going on. It's always kind of it's a bit of a bummer that we didn't have much of that today. I wish they would show us this right here. Can you see my cursor here? Like, show me this, where the Starliner capsule is firing its thrusters here that they got in mission control. That's Mission Control Houston right there for NASA. I like that view. I'd love to see that. I want to see that a little bit bigger. Let's see. Boris says, much better to watch than the original Boeing stream. A lot of useful information. Thank you, sir. Well, thank you, Boris. Thanks for hanging out here with us today. We're probably just going to stick around for a little while because there's not a whole lot going on. Maybe we'll replay the launch a little bit, or at least the first portion of the launch. Let's see. Catherine says she kept dropping off. Says good night. It's bedtime where she is. Yeah, it's almost morning time here where I am. It's 7 o'clock in the morning now. But there's a chance I may go back to bed, at least for a little while. Let's see. A lot of talk about the engines here in the comments. Gotta see elliptical trajectory. Don't they have to be in a circular orbit? Oh, yeah. So that's a good point that JQ brought up. This is a while ago in the comments here. We've talked about it a couple times here today. And Catherine also says, thankfully the ISS has cameras. We can see the capsule dock. Yeah, so we should be able to actually see views of the docking from the ISS cameras. But back to JQ's comment there about the elliptical trajectory. So I mentioned this a little bit earlier, but the Atlas, in order to have a safe abort scenario, they had to fly a very shallow trajectory, which used up a lot more fuel. This was done intentionally for two reasons. One, it was a shallow trajectory so that if they had to abort for any sort of reason, the spacecraft could come back relatively gently into the atmosphere and the astronauts would be pretty comfortable throughout any sort of abort scenario. If they flew the normal Atlas V trajectory, it's a very lofty trajectory that it's very straight up and down. That would result in very high G-forces on the re-entry portion of it if there was any sort of abort. Not good for astronauts on board. So they had to shallow that out and flatten that out a little bit. But they also did it intentionally for the Atlas V to not put it in a circular orbit. And they decided it was more efficient for the vehicle as a whole if Atlas dropped it off into a suborbital trajectory, and then the Starliner capsule and their orbital thrusters along with the launch abort fuel would actually perform the circularization. So it's the Starliner itself that will do the circularization. If something goes wrong and the Starliner can't do it, it's coming back. It's not in orbit yet. So let's see. Thanks for another great. Why hasn't SpaceX or NASA hired you to do their live streams yet? And SpaceX has a great live stream team, so they are fantastic with their streaming. Let's see. Boeing can't even. Let's see. I don't want to get too critical. It's got some talk about who's a better company, SpaceX or Boeing. We could debate that all day. I think in the end, I think we've got. It's nice to have two vehicles, whether it's SpaceX and Boeing or SpaceX and somebody else, or maybe even if it wasn't SpaceX, although I like SpaceX. But it's good to have two options for commercial crew here, just in case something happens with one of the launch vehicles, if there's some sort of anomaly during one flight, even if it's not a critical anomaly, if it's a minor anomaly and they have to go like, well, wait a minute, we better investigate this, and they have to delay flights, at least there's a second provider that can launch crew to the International Space Station in the meantime, so we don't have any delays in that regard. So having two providers, I think, is fantastic to have that. It's nice to have those two different providers available for our astronaut transports. Obviously I love that SpaceX has all their cameras available and does such a great job with the live broadcast. Makes it very exciting, especially because you can see the booster landing and all that kind of stuff. So So yeah, it's there's a lot of excitement added from some of the stuff that SpaceX does with their live broadcasts. JQ says circularization question mark. I'm not sure what the question is about circularization, but circularization or orbital circularization is basically it's in an elliptical orbit right now, where basically it's going to go up and come back down like you're throwing a baseball just on the ground. You throw it up, comes back down. That's an elliptical orbit right there. Now, for you and I don't know, might be 50 feet at your apogee, but it's basically the same concept. Just this baseball is the Starliner capsule, and it's going a whole lot faster and a whole lot higher. But at this point, and maybe it might be different now because I haven't been listening to the audio, but at this point, before circularization, it's going up, it's coming right back down. And the Starliner capsule will burn its engines to take that circular orbit, like from this, they burn the engines. I don't know, this is going to be a terrible explanation. Should just like draw it out here. Looks like this. Can you see that? Yeah, looks like that. And then the Starliner will burn its engines right about there at the dot, and they turn it into circular orbit. It's a terrible, terrible demonstration, but there's my brief explanation on it. That's my cheap and easy way to describe it. So, how many elliptical orbits does it make before it circularizes? So it's not. I guess we should be cautious about using the word orbit because it's suborbital. It cannot make multiple suborbital orbits because it's going up and it's coming right back down. So let's see. Let me draw the Earth. Suborbital means this. Can you see my thing here? So there's the Earth. This is our orbital trajectory here, right there. It's going up, it's coming back down. If they don't circularize it, it's going to land. So they have to circularize it. They burn the engines up here, and that will make it like this. My cheap Post-it note demonstration. Can you see that? So they have to circularize it in order to get into orbit, so they can actually go around the Earth and stay in space. If they don't, Sebby Time Waster just calls that a torygram. I like that. My Post-it note diagram. That's all I had available to me quickly here. I'm sure we could get an actual graphic that would show that a lot more gracefully, but I just don't have one available, so that was the easiest way to do it. But yeah, if they don't circularize, it lands. So so I guess short answer: how many elliptical orbits does it make before circularized? I'm gonna go 0, or is it 1? I don't know, but it's not multiple. I guess it's 1, or half. I don't know. It gets to the top. It gets to the apogee, the top of its suborbital trajectory. What height does it have to be to circularize? So I mean, you could circularize as long as you're pretty much in space, which is about 100 kilometers. But even at 100 kilometers in space, you're going to get some atmospheric drag. So I mean, really, you just have to be in space to. Well, technically, you don't even have to be in space. With enough horizontal speed, you could orbit at any altitude. It's really the speed that you need, but you need a whole lot more speed because of the atmospheric drag, you need to maintain a lot more speed because of the atmospheric drag if you tried to orbit at 30,000 feet. That would be very, very difficult to do, if not impossible, because of atmospheric drag. So you get into space, then you can set up your circular orbit without all the atmospheric drag. And obviously, the higher you go, the less atmospheric drag you're going to have. The International Space Station is at like 250 miles in altitude, something like that. So there we go. Insertion burn delayed. Is that? I haven't heard anything.
Flight of Starliner.
Let's see.
And flight controllers are seeing what the UMAC engines are, of course, 1,500-pound class thrusters. Each one of them, there's 4 of them on Starliner. That's what they'll use to complete the orbital insertion burn.
Sounds like, so in the comments here, we got 182. 182 is saying that the insertion burn is delayed and that it's at a bad
Starliner
attitude.
Mission Control still working through some steps to try and get Starliner in the right attitude for the orbital insertion burn. Working on the next opportunity for that, and looking to get Starliner in a good position for that.
Okay, so this is interesting. Now, they have a little bit of window of opportunity to perform that insertion burn. It doesn't have to happen at a specific instant. Obviously, there's a very optimal spot to do it at, but there's some flexibility there to actually perform that insertion burn. But it sounds like the spacecraft is in the wrong attitude.
And Flight Director Richard Jones reports that we are in a stable orbit. Starliner is in a stable orbit.
Okay. So this says we're in a stable orbit. So we're not suborbital, we're stable. But maybe we're not in an ideal, the ideal orbit that we want to be in, but we are in a stable orbit. Let's see. Yeah, so Chusicon says, so it's not pointed the right way. Yeah,
Again, Starliner is now in a stable orbit. They've got it in a stable position, but the teams here on the ground are working through what the best next steps for Starliner should be.
So it sounds like we got a little bit of an issue. So what they would typically do here is they can get it into a stable orbit, and then they can perform a series of burns to gradually make that orbit larger and larger or higher and higher in altitude. It sounds like they're in a stable orbit, meaning they're not going to come back to Earth and land. They will stay in space, at least for a short while. Eventually, atmospheric drag could potentially pull it down, but usually that could take days or weeks depending on what their stable orbit is. Gregorius says, well, going up and coming down is a stable orbit. Because it's stable suborbit. But yeah, we are orbiting right now. So we're in a stable orbit, which means it should stay in space, at least for the short term here.
And Richard Jones reports that his flight controllers are turning the Starliner spacecraft to the what we call a tail sun position. That means the solar rays will be pointing to the sun to recharge the batteries on Starliner, and of course to power the systems on the spacecraft. Starliner is in a stable orbit.
So I'm a little bit confused. I guess it would be I missed some of what they said earlier, but it sounded like they had an attitude problem. It doesn't mean the spacecraft was getting sassy, but it means that it basically is pointed the wrong direction, which is not ideal. You don't really want that to happen. And so it sounds like they're in a stable orbit, but maybe not necessarily a nominal orbit or the ideal orbit that they wanted to be in. So as long as they're in a stable orbit, then they would have a whole lot more time available to them to be able to correct that and get into whatever their nominal orbit is. Now, I don't know that for sure. I missed some of it because we were chatting it up a little bit, but it did sound like they were working through some sort of issue of some sort, but they did just say that they were turning the spacecraft so that the solar panels could charge up the batteries, which sounds to me that they obviously have control of the vehicle.
And flight controllers are working through all the options at their disposal as this maneuver to put Starliner in a tail sun position takes place. Starliner's flight path and orbit are both stable.
I do like that they've mentioned that the orbit is stable a number of times. So they seem to really be stressing that here. So let's see. It's a teenager upper stage with a bad attitude. Let's see. And Starliner should be much higher now. JQ says stable elliptical orbit. We don't know what the actual orbit is. So you can have, let's go back to the torograms on the post-it notes. Urban Spaceman 64 on Periscope says that he likes the post-it note diagrams. Let's draw it up here again. I'm gonna make our Earth a little bit smaller. Because you're gonna. So we talked about you got suborbital. You get your suborbital up here, which basically up and down is going to land. You can still have an elliptical orbit that. I'm going to exaggerate this quite a bit, but you can still have an elliptical orbit that's not circularized, and it's kind of egg-shaped, and that would be a stable orbit. Would look something like that. So that's a stable orbit. You got the Earth in the middle, and that's a kind of our egg-shaped elliptical orbit that's not circular. So they would that elliptical orbit could still keep you there in space for a while. It's just not ideal. What they would normally want to do, go back to this diagram here. This is kind of exaggerated, but they would normally want to take that elliptical orbit. Can we see that? Can you see my dotted lines there? You want to take the elliptical orbit there and burn the engines again to take it from that egg shape out into the dotted line there and make it circular. So that's kind of what they would do to circularize there, is turn that elliptical orbit into a circular orbit. So I would guess they're in a stable orbit. They haven't told us the parameters yet, but I would guess that it's elliptical, because that's kind of what you generally don't get into a circular orbit unless you're in your nominal orbit or your ideal orbit. So if they're not in their ideal orbit, they're probably still in some sort of elliptical orbit. I like Chuzikon's comment there. He's interpreting what the host is saying every time he says we're in a stable orbit. He's interpreting that to say if you're a bigwig who has any say in our funding, I just want to let you know that we are in a stable orbit, which is probably about right. Let's see.
And we do have an off-nominal insertion reported. We have spacecraft control. Guidance and control teams are assessing their next maneuvers. Spacecraft batteries are good, and the spacecraft is in a stable orbit.
Okay, so there you have it. So they've confirmed off-nominal, which means it's not in the right place. It's not where it's supposed to be. This is not the plan. It is in a stable orbit. It's just not where it's supposed to be, which is not good, especially if the attitude was incorrect during one of those burns. That would put it into an orbit that it's not supposed to be in. So you let's see, what was I going to say about? Oh, somebody said a view of the ULA control room would be nice. Yeah, United Launch Alliance is done at this point. They're pretty much packing it up and going home. At this point, it's just the Boeing team and the Starliner team that's going through all that, and NASA as well. But United Launch Alliance is done. They're like, yep, here you go. We dropped you off. Now it's up to you guys. So yeah, if you want to take a look at the United Launch Alliance mission room, probably going to see an empty room. Probably not. There's probably still there doing some more stuff, but it's the idea, though. Wouldn't an elliptical orbit require changes in acceleration? Yes. So, well...
View here inside Starliner Mission Control, where flight controllers are working through what the next steps for Starliner should be. You can see Flight Director Richard Jones standing up there beside behind the Flight Director console, talking with his team members here in the room.
Yeah, so it wouldn't... Starliner wouldn't experience changes in acceleration well, I guess potentially they could, but yeah, they're not really going to experience changes in acceleration. They would experience kind of changes in relative speed relative to the Earth, but he's asking how can astronauts handle those changes in speeds. I mean, for the astronauts, it's going to feel like a relatively stable acceleration and a stable feeling. So they're not going to really experience what you would think of as far as accelerations, because the rate of speed changes that you're seeing is relatively small for them. If the insertion was wrong, then ULA might be fielding some frantic calls right now. Oh, I guess I didn't think about that. Chusakan mentioned that as well. I guess I didn't think about that, and because we weren't listening, we don't know how it got into an off-nominal orbit. But I don't think, it doesn't sound like it was anything from the Atlas V. It sounded like the Atlas V dropped it off in the correct suborbital trajectory. Sounds like it was the Starliner that started doing its orbital insertion incorrectly. Can you explain how it...
And once again, we have had an off-nominal insertion. We have spacecraft control, guidance and control teams here at Starliner Mission Control are assessing all their options, and contemplating the next maneuvers for the spacecraft. Starliner has good batteries and is in a stable orbit.
And the flight control team also reporting that Starliner did finish moving into that tail sun position that will allow its batteries to recharge.
Yeah, so it sounds like they're going to have to do a little bit more. This could be... They haven't given us any sort of orbital parameters, and I doubt they will. So this could either be a major problem that could jeopardize the entire mission if they're in an orbit that it just can't recover from. I would doubt that. I would think they should be able to save this in some sort, but they may need to use more fuel than they planned on. So they're going to... They're trying to figure out what they're going to do next. We get a little bit of an audible here going on. Yeah, and I wish it would be nice if we had some sort of like orbital parameters so that we could actually see what sort of orbit they're in right now. Like how far off are we at this point? But I'm sure they have that. Well, I know they have that available for the people there. But they don't necessarily want to share that with the general public. But if you're an astronaut here and the next flight of theirs is going, I don't know, I guess this is the problem that I would have with something like this, is that the next flight is going to have crew on board. Now, this isn't dangerous for the crew. It's just not ideal here. I mean, the crew would still be safe and sound and be able to either come back home or potentially get to the International Space Station. But they, obviously that's going to be a little bit concerning for them, knowing that this isn't it where it's supposed to be right now. Let's see. Sorry, I was checking the Twitter machine, trying to see if there were any other updates that I missed. Oh, here we go. A couple people in SP Sam over in our Discord channel was throwing throwing some updates over here. Capsule is not pitching over properly. This is from space.com. It says capsule is not pitching over properly. Not very much time before they either have to light the thrusters or try to re-enter over the Indian Ocean. that was.
And if you're just tuning in, Starliner lifted off from Cape Canaveral, Florida at 6:36 Central Time this morning. We have had a off nominal insertion, and mission control teams here at Starliner Mission Control are assessing all of their options for the Starliner spacecraft. It is in a stable orbit, it has power, and its solar array is facing the sun to recharge its batteries further.
All right, so we talked about they had to either light the thrusters or try to re-enter, and then we had an update that said the orbit is stable but very low orbit right now. Looking at Jonathan McDowell over on Twitter, he also said technically 73 by 181 kilometers is
An
an
orbital insertion
orbital
burn was
insertion.
scheduled to take place 31 minutes after launch, but didn't happen on schedule. Again, teams here on the ground are evaluating their various options, looking at what the best next steps for Starliner might be.
So I'm looking at Lauren Grush on Twitter, and also Jonathan McDowell, and so this is. So now they're talking. So Jonathan McDowell said technically 73 by 181 kilometers is an orbital insertion, just not one that will result in more than one orbit. So what we've got here, it sounds like if those are the correct orbital parameters, it sounds like if they don't do something soon, they're going to only get one orbit out of this. But they did do that whole tail sun position pointing to get the solar arrays powered up, but so it sounds like they have control of the spacecraft, but I don't quite understand what happened, which Lauren Grush also said on Twitter, said she's very confused. Let's see. What else did we miss comments-wise? Wow, Amateur Hour, SpaceX does better. Does anyone know where we can view it? Let's see. I think in an elliptical orbit, the astronauts would not experience any acceleration at all, but I could be wrong. Orbital dynamics is extremely complicated. We're just amateurs here. Yeah. I don't think they experience. I guess if you got some sort of change in speed, they would have. I don't know. I'm trying to think this through in my head. I would think they would experience some sort of G-force if they're in an elliptical orbit. But I guess depending on how elliptical, it could be very, very small. And that's why this is 181 by 73, which is technically an elliptical orbit, but it's very close to a circular orbit. It's just not perfectly circular. I imagine, I don't know, in my head I'm thinking, somebody maybe that's in aerospace, maybe you could explain this a little bit better, but I'm thinking in my head if it's a super elongated elliptical orbit that and then maybe you would experience some higher G-forces at perigee, which is the closest approach. That's when the vehicle is going the fastest. But I don't know the answer to that. I have no idea. Question. Yeah. So Gregorius points out a good question. The question is, do they have enough fuel to correct the trajectory and complete the mission? That's going to be. That is going to be the big question here. Is can they save the mission and fix this and still go dock with the International Space Station, or are they going to have to come home? Because if they can't fix it, they could be coming back in, I don't know, we're at about T plus an hour. They could potentially get only one orbit in and then have to come back home. And so I don't know the answer to that here. Sorry, I'm trying to listen very carefully because you guys probably can't hear this, but in my ear I can hear just the faintest of talking. It's very, very quiet. And it's so quiet I can't even understand what they're saying, but I can hear a tiny bit of talking, almost like somebody has the microphone or the volume turned down, but not all the way down. So it's very, very quiet. So this ought to be interesting to see what happens here, whether or not they can actually save the mission here. This is probably a little bit stressful for them. Let's see. Catherine's talking about when it comes around the side of the planet where ISS is, does the ISS have telescopes to locate Starliner as it orbits? I don't know of any like telescopes that they have. I mean, I know they take photographs and they've got video cameras and things like that available to monitor it, but I don't know if they'd be able to monitor it at this point because it's still pretty far away from the International Space Station, relatively speaking. I mean, I guess in some sense it's still pretty close, but in another sense it's still very far away. Let's see. Yeah, we're well, let's take a look at look at more comments that I'm getting alerts from on Twitter. Somebody said, this is Chris B from NASA Spaceflight.
And once again, if you are just joining us, Starliner lifted off from Cape Canaveral, Florida this morning at 6:36 a.m. Central Time to begin its chase of the International Space Station. We have since experienced a off-nominal insertion, and the spacecraft has essentially is in a stable position. It's fully powered. Mission Control here in Houston is assessing all the options. We're going to step away from the broadcast, and you can stay updated on everything that is taking place with the Starliner mission on Boeing.com.
We'll also be getting you more information here on NASA TV as the morning progresses. Thanks so much for joining us today. We're going to sign off for now, but we'll have more information for you soon.
Well, that's interesting. So they've aborted the broadcast. They've had enough, and they're just gonna leave it there. So
hey.
Hey. All right, back it up. We'll just put this pretty little screen up there. Maybe, possibly, maybe not. I was gonna try to leave it on that logo. But yeah, so it looks like they're gonna abort the broadcast here, and they're gonna leave us with this, which that's fine. And now we just get to speculate a little bit on what's happening here. So. But this kind of fits right into the point that I was about to make right before they came back and talked, which was Chris B from NASA Spaceflight on Twitter said, it's never a good sign when NASA TV goes silent, repeating the same line or just repeating the same line over and over again and won't mention why. That sends shivers down my spine. Yeah, so that's, we've got some sort of issue going on here, which is this is not good for Starliner. I mean, the immediate thing here is they got to make sure that they can get it into orbit and that the mission isn't going to be over. So that's probably priority number one, trying to make sure they actually can make a mission out of this, because if they don't figure it out, they're coming home and that's the end of the story, at least for this flight. And that they're probably going to have to do another orbital flight test, I would imagine, they're going to have to do a redo. But if they can figure it out and they can correct this issue, then they could save the mission and complete a whole bunch of demonstrations and then just have a minor tweak or something like that they have to fix come crew flight test time. Abrupt broadcast cutoff is very, very bad. Yeah, it never doesn't make you feel good when they're like, they come back from a long silence and they're like, yeah, you know what, we're leaving, so see ya. We'll post updates online later. That doesn't make you feel real good. Let's see. Jim Bridenstine, the NASA administrator, posted on Twitter, says Starliner is in a stable orbit. The burn needed for a rendezvous with the International Space Station did not happen. They are working the issue. So my confusion is, and I think this is where a lot of people's confusion is on Twitter, is they said in the press conference that Atlas was going to drop off. This Chris G on NASA Spaceflight saying the same thing. I'm honestly very confused. Somebody needs to answer how in the heck Starliner is in a stable orbit if the orbital insertion burn did not take place and it was a suborbital Atlas V drop-off, which is exactly what I was about to say. And actually, Chris G asked this question at the press conference yesterday or the day before. He said, okay, Atlas V is going to drop off in a suborbital suborbital trajectory. What are the parameters of that? And I think they said it was like 89 by 39 or something like that. 39 kilometers being the closest approach to Earth. 39 kilometers is not enough. That's not a stable orbit. 39 kilometers is putting you back in the atmosphere. That means it's coming back. So it's not, I guess it's let me go back to my post-it note diagrams. It's not this that's the suborbital it's more like this, but this close approach down here is only 39 kilometers. That's way too far back into the atmosphere for it to stay into space. And so that was the plan. That's where Atlas V was going to drop off the vehicle, was in I want to say it was 89 or maybe it was 90 by like 39. So not a stable orbit. Now, they said that they had trouble with, if you're just joining us here, we'll talk about what just happened. They said that the orbital insertion burn did not happen, but somehow they're in a stable orbit. This makes no sense, and nobody understands what's happening right now, because how they could go from a suborbital orbit into a stable orbit without having any sort of burn is very confusing. Something happened. Either the Atlas V dropped it off in the wrong orbit, which doesn't sound like happened. It didn't really seem like there was any sort of indication of an anomaly from the Atlas V part. So either Atlas V dropped it off in the wrong orbit, but a stable orbit, so it's still in space, or there was some sort of burn that happened earlier, at some point, to put it into a stable orbit. So yeah, we're very confused on what the orbit is here. And we quoted, Space Gal, I think it's Alicia down in Florida here, joined in and said, follow Planet 4589 on Twitter. That's Jonathan McDowell, who we were quoting a little bit earlier. He gave some numbers out, but it sounds like he was just throwing those out theoretically, because nobody has told us what the perigee height is or altitude is. So what's the closest approach to Earth? Like what is this stable orbit? Is it stable? Like, define stable orbit. Are we talking stable orbit like this is going to stay in orbit for 3, 4, 5 orbits around the Earth? Or stable orbit meaning like we can make one lap and then we're going back? Because that's what it sounds like to me. It sounds like maybe we can get a lap in and then we're either going to come back home or we got to fix the problem. So that's the big question, which everybody is very, very confused about right now. We're just trying to figure out, how did we get into a stable orbit? Don't quite understand. I don't quite understand how that happened. And the big question is, are they going to be able to save the mission? A lot of people commenting, especially media. Jeff Faust on Twitter says, NASA TV signs off after again reiterating the spacecraft is in a stable orbit, but without giving the orbital parameters or additional details about the issue. Yeah, so a lot of people very, very confused on what's happening here. We're not sure what's happening. This is perplexing with NASA and the old school guys launching rockets higher than the cloud. Gregorius also said, is the rocket in a ballistic trajectory and they're just saying stable orbit just as a PR move? We don't know. Let's see. Looks like United Launch Alliance is half a year back with plans after that. Well, it sounds like United Launch Alliance did what it was supposed to do. Remember, there's two companies involved here. It's kind of confusing because United Launch Alliance also includes Boeing, but United Launch Alliance did the launching of the Atlas V rocket, and this is my interpretation, but it sounds like the Atlas V performed nominally and dropped it off correctly. I don't know that for sure, but that's what it sounds like to me. The Boeing Starliner capsule, which is not run by United Launch Alliance, was then supposed to circularize that orbit, do an orbital insertion burn to circularize the orbit, which would allow it to rendezvous with the International Space Station. That did not happen. They're trying to figure out how to recover from this. That just did not, it did not happen, but yet still somehow they're in a stable orbit. And it's very, very confusing. Nobody knows what's going on here. Let's see. Space Gale says, and next are they sending astronauts or not? Yeah, that's going to be another big question. Because if they did not reach a stable, or if they did not reach the intended orbit and they can't recover it, it's going to be coming back. And then they're going to have to do another orbital flight test. They're going to have to redo this because they have to do all the demonstrations with approaching and docking the International Space Station. So they're going to have to reschedule and redo this whole thing if they have to basically abort this mission early. So yeah. Let's see. The capsule. I'm too afraid to open my Twitter because it'll explode with tweet. Yeah, I'm kind of looking at Twitter here now. I guess we could probably pull it up so we can all see what's happening. But let's see. I'm kind of just. I was looking on my phone here, but a bunch of good sources. Yeah. I'm looking at NASA spaceflight. We're looking at Chris G at NASA. Here we'll switch over to this here. Let's see. This way we want here. Let's full screen this and go like that. Yeah. So we're trying to keep an eye on Twitter, figure out what's happening here, what is going on. Chris G has said that they have a 9 o'clock press conference, which is still going to happen. So there's that. They're trying to track down information, but it sounds like NASA and Boeing have just gone radio silent at this point, which is very, very concerning, especially since there's clearly an anomaly here. I mean, to just go radio silent like this is, I don't know, it's kind of crazy. Like, people want to know what's going on. Is Starliner, if this news conference is at 9 o'clock in the morning, if this barely has enough to do one orbit, then Starliner might be coming back to Earth right around the time of that press conference. So I don't know. Let's see. So So Jim Bridenstine said that the orbital insertion did not happen, but I don't know how we got into a stable orbit. And then NASA TV just went away. Everybody's very confused. Like, Chris G is very confused. We don't know what's happening at this point. We were just told at the KSC press site that an update is forthcoming in a few minutes. Okay, we'll stay tuned here for a few minutes and see if we get an update. But just to figure, I just want to know what happened. Like, how did it get orbital if it got dropped off in a suborbital trajectory? A couple nice pictures there, at least. But that's the most confusing thing for me right now. I gotta go back to the screen so I can see your comments again. But that's what I don't quite understand. So it sounds like we should have some sort of update here in at least a few minutes here. I'm trying to trying to keep an eye on Chris G is a very very reliable source from NASA spaceflight. Awesome guy. So we're gonna keep an eye on his Twitter here and see if we can figure out exactly what's going on. But yeah, it sounds to me like Starliner's coming back. Like it's gonna re-enter. But we should have hopefully an update here in a few minutes. Chris G says that there's an update forthcoming. So is the press conference in an hour? Yeah, the press conference is not for like another 70 minutes. Hour and 10 minutes is when the press conference is. But Chris G from NASA Spaceflight, there's two Chris's at NASA Spaceflight. Chris G from NASA Spaceflight said that there's an update coming soon. So hopefully that's like really soon, within a couple minutes. Well, he actually said there's an update forthcoming in a few minutes. So hopefully we should have at least a little more information in just a couple minutes, and then I'll probably leave you with that. But let's see. This sounds very unsafe. We have an unmanned rocket traveling 1,000 miles per hour. This is not where it's supposed to be. Well, don't forget, so this is JQ over on a YouTube channel. These orbits are designed to plan for this scenario. So they have an abort trajectory in place that if the orbital insertion burn doesn't happen, it will abort into a safe area. And actually there's already NOTAMs, there's already maritime warnings and things like that for the spot where Starliner would land in a failed orbit insertion like this. So this is planned for. I don't think it's unsafe. If there were astronauts on board, they would be safe. This entire trajectory and this entire scenario is something that they have completely considered and completely planned for. And so the outcome of this should still be safe and relatively, I don't want to say routine because this shouldn't happen, but it's planned for. So it shouldn't be that big of a deal. Let's see. All right, Scott Manley, Gregorius says that Scott Manley said Starliner was pointed at 90 degrees to prograde when they were trying to perform orbit insertion. So it sounds like maybe they they did a small amount of an orbit insertion burn and then went, uh-oh, this isn't right. Because 90 degrees to prograde would basically mean like, well, we're going back to the Post-it notes again. I really need like something I can draw on the screen. That would be kind of nice, right? So 90 degrees to prograde would be if you're in an elliptical. Here's my elliptical orbit again. If you're in your elliptical orbit, in order to circularize, you need to burn the engines. You need to burn the engines that way. See my arrow? If you're 90 degrees to prograde, then they were actually burning the engines that way. That's not good. And whether they actually burn the engines or not is still kind of up in the air. My little Post-it note. It's gonna be a goal for the next time. Is I need some sort of like Earth mapping whiteboard that I can just draw on the screen so I can show you all this stuff instead of doing it my Post-it notes. Let's see. What's not safe is Boeing's face. Yeah. Well, yeah. This is not going to be good news for Boeing. At least not if they have to redo this. I mean, it might not be a disaster, but I don't think we're talking like tons and tons of delays. If this, let's say worst case scenario, Starliner comes back, re-enters Earth, lands, and it's basically an abort scenario. I don't think we're talking huge delays. They probably have to correct whatever the issue is, but they will still be able to. They'll have to redo this mission, and then they will then they'll move on to crewed flights. So basically, they're gonna have to have a redo of this, which should definitely cause a delay. Hopefully not crazy long delays, but at least a couple of months, I would think, or at least 8 months, for them to reset and redo this mission. I would think that they have to do even longer than a month, because they don't have a vehicle ready to fly to redo this mission. So that's going to be a problem. Let's see. Well, the astronauts can always override the computer. Is this what? Wait, what? This is. Let me go back a couple comments. Somewhere Elon Musk is chuckling. What's if there were astronauts on board, wouldn't they be controlling the capsule to correct the orbit? Most of this stuff is automated, so they usually don't. They have manual override capabilities, but I think most of those manual override capabilities are for docking purposes. Most of this stuff is completely automated. How do they burn in space? Well, in order to burn in space, you got to bring your own propellant, but you also have to bring your own oxygen, because without oxygen, nothing burns. So they have their own propellant, and they bring their own oxygen or oxidizer of some sort. Like, you know, your typical rocket would use, or like the Atlas V. I think the Atlas V is the Atlas V hydrogen based, or is it kerosene based? But the like SpaceX is kerosene based. They use rocket grade kerosene, and then they bring their own liquid oxygen. That's why those two things are part of their fueling. So then they bring their own oxygen so they can actually burn in space. Let's see. The propellant is 2 parts, contains oxygen to be able to, you know, your oxygen or your oxidizer to be able to burn in any environment. But yeah, you have to bring your own. Bring your own oxygen. Let's see. Rockets can do burns in space because the fuel is mixed with oxidizer. Basically, the rocket carries its own oxygen. Yep, yeah, so that's basically what we were all talking about. So South Texas guy says he just jumped in. We have a booster issue. No, the booster seems like the booster was fine. The problem is that the booster dropped this off into a suborbital trajectory. The Starliner went to go circularize its own orbit, which was part of the plan. And the orbit insertion burn that the Starliner was going to do, not the Atlas V. The Atlas V seems to have worked just fine. But the orbit insertion burn that Starliner was supposed to do failed. They had an attitude problem. The capsule got a little sassy this morning. No, attitude problem meaning it was pointed the wrong direction. According to Scott Manley, it was pointed 90 degrees, 90 degrees to prograde, meaning it was pointing 90 degrees the wrong direction. And so that did not happen, and it went. And now we're somehow still confusing. We're in a stable orbit, but let's see. SpaceGale just sent me this on Twitter. Said this is from Thomas Burkhart. Says while we wait for an update on Starliner status, it's worth mentioning that part of the reason for the initial suborbital insertion was to prevent Starliner from being stranded on orbit if its engines failed. Right. Yeah, that was the idea. Or that was part of the idea, was that if the Starliner engines failed, it would re-enter. But it sounds like the engines may not have failed, but the capsule was pointed the wrong direction, so they might have burned at least a little bit, because they're now in a stable orbit. We don't know how far that stable orbit is. We don't know. It sounds like it's elliptical, but we don't know what the perigee is, or the closest approach to Earth. Like, is perigee going to be in the atmosphere? Like, are they going to get one orbit out of this before they get atmospheric drag and come back to Earth? Are we going to get a couple orbits out of this? We don't know the answer to that. But they say they're in a stable orbit. I don't know how that's happened, but it sounds like, unless they fix something, that it's going to be coming back to Earth. So this mission may be this mission might be completely aborted. Let's see. And Alicia says attitude controller must have acted up at the wrong time. It went northeast, was to go to east. Well, the trajectory, so the inclination, this was like a 51-degree inclination orbit, which is the same as the International Space Station. So the actual orbital path would have been northeast. But in order to circularize, they would have had to done a prograde burn. Meaning, go back to where's my post-it notes? I got too many post-it notes here. They would have had to do a prograde burn, basically in the direction of travel to circularize. And according to Scott Manley, it was 90 degrees to prograde. So if the spacecraft was traveling this way, they would, instead of burning in that direction, the spacecraft turned and burned this way. Which doesn't, unless you played Kerbal Space Program, probably doesn't make a whole lot of sense. But it doesn't mean that the spacecraft is just going to shoot off into space that way. You burn this way, it's going to do some weird things with your orbit. I don't know exactly off the top of my head, but it would just like extend your elliptical and make it fatter. Yeah. Anyway, so South Texas guy says, I saw a 40-mile perigee somewhere. That's bad. So I think it was 40-kilometer perigee was the intended perigee for where the Atlas V was going to drop off the Starliner. It was supposed to be 40. I think it was 40 kilometers was the perigee, which is too low to stay in space. But that was intentional so that if something went wrong, it would come back to Earth. And then Starliner was supposed to circularize that. Now, somehow we've gotten into a stable orbit, but we just don't know how that happened. Let's see. Shouldn't it re-enter already? Yeah. So that's the other thing is if those engines failed, the re-entry of Starliner was supposed to be like 30 minutes after launch, which we're well past that, and it's still in orbit as far as we know. Waiting on some information here, but we just don't know. We don't know what kind of orbit it's in. Like, it could stay up there for a couple of revolutions, or it could be coming back any minute. Let's see. All right, let me go back to some comments here. Sad day, yet more money to new school. I don't know what that means, but yeah, I mean, it's definitely, it would be a sad day if they're not able to save the mission, because it just means more delays, and it's going to be a while before we get commercial crew going. Oh wow, didn't know I had my sound on. That was loud. It'll be fun to see how this all ends. Yeah, I don't know how much longer I can keep going here. I had already planned to end the broadcast, but now I'm very interested, and I wanted to see if they're going to give a quick update here before I have to go. What is a propellant push off of in order to correct course? Yeah, so propellant, it's not quite how rocket propellant works in space, right? I guess the propellant pushes off of the engine itself. So there's a couple things that happen. You've got your thrusters, like attitude control thrusters. Those are all under pressure, and so all you have to do is expel mass in order to create forward momentum. As you just say, it's like if you can simulate that on the ground, is if you sit in a rolly chair like I'm in right now, and you were to throw a ball away from you. If you have some mass, have a heavy medicine ball or something like that, and you were to throw it away from you, you've ejected mass that will create acceleration in the opposite direction. So the thrusters are under pressure and will eject gas to thrust again to get moving. And then you've got your regular propellants. This is what like the SpaceX upper stage does when they relight. Problem with the regular propellants is they kind of just slosh around in the tank when you get into 0 G, And it's really hard to get propellant to go out the bottom of the tank when you're in 0G, because there really is no bottom anymore. It's just kind of all floating around in there. So typically what they do is they will ignite the thrusters briefly to push the vehicle forward, which forces the propellant to the back of the tank and out the bottom of the thing. So they thruster forward, propellant goes back, and then they ignite the engines. And then once they start igniting, then you've got lots of acceleration forward, and all the propellant gets pushed towards the back of the tank or the bottom of the tank. So there's that. That's how your rocket engines work when you're in space. Wouldn't a 90-degree to prograde burn only delay its eventual reentry due to non-circular suborbital drop-off? Yes, theoretically. I mean, it depends on how long they burned or which direction they burned up. But yeah, I mean, that's kind of it's basically the theory right now is if they did burn 90 degrees to prograde, I mean, it might pull the perigee up a little bit, so you might be able to get away with one revolution. But I don't think you're going to get more than that. Not much more than that. So, let's see. Rocket Bell pushes off combustion. But yeah, okay. Thanks to Scott Manley video sleuthing, the stage burn was done off axis. Is that the stage? This is Gregorius saying you're talking the stage burn for like the Centaur upper stage was incorrect. That would be interesting. That would be that's not what I thought was going on, but it'd be interesting. They're venting something into space. Gregorius now says it was pointing 45 degrees off axis, not 90 degrees. Can you tell me what kind of stabilizers are used at launch while the rocket gains speed before there is enough wind resistance for fins to do anything? I can't find any info on it. I'm a little confused on that comment because at most modern rockets don't really use fins anymore. They use thrust vector controlling, so the stabilization is actually caused by the engine gimbling. So the engines move around to direct the rocket which direction it's going to go. They can also do roll control as well with the engine thrust vector controls. So they don't really use fins anymore. I mean, your fins can cause or provide stabilization, but yeah, a lot of the modern rockets, like your Falcon 9 or even the Atlas V, they don't use fins anymore at all. So it's not really an issue. They just use thrust vector controlling. Commercial crew, despite launching successfully, Starliner spacecraft currently a stable configure. Yep, that's pretty much a rehash where we are. How does it turn? We got thrust vector control for turning in the atmosphere. You've got thrusters. It'll also, the RCS thrusters help it control attitude and turn in while it's in orbit and in space. Let's see, this is turning into the most educational launch so far. Great fun. I know, right? We're talking about a whole bunch of things. It's possible it could fall on land somewhere. This is scary. So again, this is a planned, well, it's a relatively planned abort scenario. Although if they did some sort of minor burn, it could be in the wrong abort. And that may be what the consideration is. They could, if it's in a stable orbit, one of the considerations might be like, okay, we're not going to recover this mission. How can we get it back to Earth in the safest way possible? So, they're probably looking at that. All right. So Chris G on Twitter says, big consideration for the continuation of Starliner's mission is that it can only free fly for a total of 120 hours over the mission. That will also have to be accounted for in any determination if the mission can continue to the ISS after they fix the issue. So that's a good point that I didn't even think about, is that all of these vehicles, Crew Dragon and Starliner, both of them have issues with how long they can fly by themselves on battery power before they have to either come back or hook themselves up to the International Space Station. These are not meant to be long duration vehicles that can just free fly in space for days and days and days. They're supposed to connect to the International Space Station in order to receive power and batteries and, you know, get all their supplies back to where they need it, and then after they disconnect from the International Space Station, it's a relatively quick 4 hours back to Earth. So environmental control systems, batteries, all that kind of stuff is not meant to be super long term here. Okay, so what else did we miss here? I'm way behind on comments, but I'm trying to get through all of them here. Let's see. I hear children, Tori. Yeah, those are my kids in the background. It's morning time. They're all waking up, getting ready for the day. Can't believe we allow companies to launch stuff like this over our heads. A lot of dangers involved. I mean, it's not. But I mean, this launched out to sea, and they planned this accordingly. So basically, like if it completely failed, it would have come back and landed in the ocean in their abort designated area. That's basically a ballistic trajectory. So that's completely planned. If they get into a stable orbit, which is what they've said that they're in a stable orbit, that's actually very good because they have much more control over where it comes back. If they're in a stable orbit, they can, even if they're like, all right, we're not going to make it to the International Space Station, we're not going to have enough hours to do it, we don't have enough fuel, blah, 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 they could still maneuver the spacecraft into a slightly different orbital path or decide to come home at a more optimal time so that they are safely coming back. So I wouldn't be too worried about the safety aspect of it. I mean, these are all things that they've thought out. Let's see. Yeah, and Sebi Time Waster said this is also designed to land on land. So that's a good point too. Obviously, you don't want to land in the middle of a big city, but yeah, this is designed to land on land. So you could pick remote areas of the world to land in, and these are all things that they've got a million different thought out plans for, like where they can bring this spacecraft down. So it doesn't always have to be in the ideal spots. They have backup places and abort scenarios and things like that, so they can get it back safely. Let's see. Without computers at all, it's not possible. Yep. They publish these precautions someplace. So they do publish what are called maritime notifications and NOTAMs. NOTAMs are notice to airmen, which are basically notifications to aircraft and things like that there's dangerous activity in a particular area and to stay out of there. The notice to maritimer, I think it's called a NOTMAR, basically the equivalent for ships and things like that. They're also notified for certain areas to stay out of during activities like this. Let's see, it was pointing 45 degrees off axis when it was performing the circularization burn, but it might end up at 90 degrees at the end. Yes, okay, so that makes a little bit of sense. I'm reading the next comment here. Yeah, so it sounds like Atlas V did what it was supposed to do. It's the Starliner's orbital control thrusters and attitude control thrusters that maybe got it wrong. Anyways, I was laughing at Chusakon. This is a few minutes later, but Chusakon is laughing at me for saying they do roll control with that for a few minutes ago. Yeah, there's my explanation of thrust vector controlling. I'm not educated on what it would take to make microsecond adjustments. Is it some sort of supercomputer or just regular speed computers? I don't know specifically what the Atlas V uses or what the Starliner uses, but I know the SpaceX stuff is actually pretty readily available computer equipment. It's nothing like crazy hardened or something that's not completely available for other commercial entities. So they usually, yes, they're making quick decisions in the order of microseconds, but pretty much any modern computer can do microsecond decisions at this point. It doesn't really have to be like some crazy supercomputer that does all of that. A lot of what they have is redundancies on board, so they'll have multiple computers available so that if something goes wrong, or like the SpaceX has 3 redundant computer systems on board, so if one of them disagrees with the other two are like, hey buddy, you're wrong, restart yourself, get yourself up to speed. So they have some redundancies in place there. Relatively small computers, yeah, nothing super needed. How does it even know to make adjustments without anyone on board? So those are all the sensors and the software programming. So, so you're using, you know, guidance control, GPS systems to figure out where it's located, sensors that figure out how fast it's going, what direction it's pointed, how fast, you know, what kind of acceleration it's under, what kind of pressure it's experiencing, what all the fuel systems and control systems are doing, and all that sort of stuff. And basically it's all software. They just write it all in, and the vehicle is very aware of where it is and what it's doing at the time and can make adjustments to it. Under normal circumstances, obviously the Starliner has some sort of issue because it wasn't aware of which direction it was pointing, or thought it was pointing one direction and it was not. Yeah, Joe Barnard from BPS Space, he uses thrust vector control for his Arduino-powered model rockets. He also does, he's got his little RCS system, which I haven't seen fly, but he has an RCS system for doing thruster control too, which is kind of crazy. I'm not on a stable orbit, falling asleep rapidly. Now I really have to go. Bye, everyone. All right, bye, Catherine. Thanks for joining us. Let's see. All right, I think I got caught up. So Space Gale says Boeing will have an update soon, Chris just said. So yeah, we're still waiting for some sort of update to see if we've got any more information. So, there we go. So Emery Kelly, Kelly's a spaceflight reporter from Florida Today, which is part of the USA Today network. He said he's confirmed there was no issue with Atlas V ahead of Starliner's orbital issue. They're trying to get a briefing together. So there you go. There's confirmed by Emery Kelly from Florida Today, part of the USA Today network, that Atlas V had no issues. Atlas V worked exactly the way it was supposed to. So it's good news for United Launch Alliance, bad news for the Boeing Starliner team. And so, okay, so there's, let's show this. Let's show, Scott Manley put up a cool animation. Let's take a look at that real quick here. Let's see if we can pull this up. So Space TV just joined us, says, what did I miss? Well, you missed a bit. Let's see, where is that animation here? Okay, we'll throw that up. It's kind of grainy. It's going to be tough to see, but let's recap here. So if you're just joining us, we had a successful liftoff of the Atlas V rocket carrying these Boeing CST-100 Starliner, part of the Commercial Crew Program, uncrewed. It was, it launched. Atlas V worked perfectly, separated the Starliner capsule, and then that was in a suborbital trajectory, which was planned, no problem. Starliner was supposed to circularize that orbit and burn the engines to get it to where it was supposed to be. That did not happen. Or, there's a little bit of confusion. It did not happen the way it was supposed to. For everything they've said so far is that it did not happen. Something must have happened because it's in a stable orbit of some sort. So some sort of burn must have happened, at least a little bit. And that's what we're going to look at here from Scott Manley's video clip here that he grabbed just a second ago. But anyways, so Starliner is in trouble. It is not in the correct orbit. We don't know if they're going to be able to continue the mission. It sounds like they will not be able to, but we don't know the answer to that. It's running out of battery power, and environmental control systems are going to not be able to handle this, which is not really an issue for this because it's uncrewed, but battery power will definitely be an issue. It's not meant to fly for more than 120 hours, so They may not have enough time to rendezvous with the International Space Station. They may not have enough fuel to rendezvous with the International Space Station. So they're trying to figure out what to do. We've heard relatively little from Boeing and NASA. Hopefully they'll give us something soon. But that's what's happened and what the problem has been. So it sounds like this mission there may be a problem. So anyway, so here's what, let's go over to here. This is from the broadcast earlier. Scott Manley took this clip, and the reason it's so grainy is basically he zoomed in on it. This was not actually shown on the broadcast, but it was in the background of the broadcast, and so he kind of zoomed in on this, so it's a little bit grainy. But what we're seeing here, when I press play, you may be able to see it, but here's a Starliner with the thrusters that are supposed to be firing. If you look closely, there's going to be a bunch of lines here that are kind of the attitude control, and prograde is indicated by this red, I think it's a red line that goes like this direction. And you can see that the Starliner, so Starliner should be burning its engines prograde in the direction of this red line in order to circularize that orbit. It's not, it's 45 degrees off of that axis. It should be right down here. So if we hit play, I don't know if you're going to be able, hit play, play. Okay. Okay. What happened? Play. There we go. Oh, here's your, oh, actually, here's your red axis here. I don't know if you can see this. So this is actually like sideways, it looks like. Now we're just spinning. Oh, media cannot be loaded. What's happening? There we go. Okay. Now we're playing. So, yeah, this is like sideways that it's burning its engines, that it looks like to me. Can we play it again? Play it again. Wow, this video is really freaking out. It does not want to play. Okay. Well, anyways, so that... what's happening with this? So, yeah, that does not look like it's going the direction that it was supposed to. Let's see if this will play again. Let's go back here. It's really hard to see. I don't know if you can see this red line here. I think you can see it a little bit. But the red line is right here. That's prograde. That's the direction it's supposed to be burning its engines. This looks like it's sideways and tilted down a little bit. It's completely the wrong directions. And you can see at the end of it, it looks like you have engine activation. Like right... it's only a couple second clip, but right about there. Like, see here, these are the engines that are activating. I don't think those aren't thrusters. Those are the engines. So it looks like we got a little bit of an orbital insertion burn. Maybe not for very long, but we got a little bit of a burn. So that's going to be problematic. Let's see, did we get anything else? This is what mass confusion looks like. We should pull up, just pull up the Twitter feed here so everybody can see. This is definitely mass confusion. I'm very confused. It's crazy how they don't, that we don't have any updates here. All right, let's get, I'll get you over here. We'll go to the Twitter machine. All right, so what am I looking at? So there's the video that we just saw. Here, thanks, Jerry, for sending me this. Jacques from Goddard. Yeah, this is what Jackie. I'm assuming that's Jackie, but yeah, there you go. Mass confusion. This is the scene from Jackie Goddard. Is a correspondent from the Times of London. This is the scene at NASA right now. It's a little bit of confusion. Everybody's all fired up. I don't know who I think that's Ken Kramer right there. I don't recognize anybody else from the back of people's heads here. Only recognize just Ken Kramer, but everybody's very, very confused on what's going on. Let's see, Space Gal sent me something from NASA, Boeing Starliner update. here we can go here. I'm looking at this blog here. Boeing Starliner, despite launching successfully, Boeing CST-100 Starliner is not in its planned orbit. Spacecraft currently in a stable, oh, they changed the wording here, stable configuration while flight controllers are troubleshooting. That's a little different wording. Stable configuration and stable orbit. Big difference there. Subtle, but big difference. Starliner has an off-nominal insertion, but Boeing has spacecraft control. Guidance and control team is assessing their next maneuver. Boeing is separated from the Atlas V Centaur. Yeah, okay, so those are the updates that we knew about. So, yeah, that's what we're at here now, folks. And I really have to go because got stuff I got to be doing. But this is exciting and confusing, and I don't know what's happening. Let's see. Wow, I missed a whole lot of comments. Let me back it up here. Any new news? Nope, I don't know anything new right now. Is there a problem? Yes, we do have a problem. All right, let's see. Let me back up the comments. Let's see. JQ says my GPS doesn't even work when I'm on my boat more than a few miles offshore. Well, GPS should work. GPS is satellite based. That should pretty much work anywhere in the world. Unless you got, so a lot of GPS, here's the confusing thing. A lot of GPS devices use like LTE service to load like the map tiles to show you where it is. Like it might know your coordinates, whatever it is, 36.24 by negative 80.76 or, whatever your coordinates are. But it might not be able to display it to you. It might require like LTE service or 3G service or some sort of data connection to actually display the map. But the actual GPS itself to get coordinates, that should work anywhere in the world as long as you got a clear view of the sky. Let's see. Yeah, ULA hot potatoes, all the blame onto Boeing. So it sounds like rightly so though. Oh, hi, Sandy's at work but trying to jump on. Hi, Sandy. Thanks for joining us for a few minutes during our issues here today. My Twitter is exploding with speculation. Yeah, right. Everybody's all confused and speculating. We have a missing capsule. It's not really missing. We know where. Well, somebody knows where it is. We just don't know. Can you help me understand why there's no GPS in the southern oceans or over deep jungles like the Amazon? Nope. I think GPS is everywhere. I mean, I'm pretty sure we have global coverage of GPS. And, let's see. Boeing went dark, yeah, and so did NASA, pretty much. Let's see. That's true, yeah. So Grigori, going on the GPS issue. Interesting thing about GPS is there are a whole bunch of different modes for GPS. So depending on the receiver you have, the receiver can be like if you have a pedestrian-based receiver, it's expecting you to walk at very slow speeds and change your location very slowly. If you change very rapidly, it can confuse the GPS because it's not expecting that. Same thing, like we run into this with our weather balloon flights all the time. You can't use, our GPS chip has different configurable modes. You can't use pedestrian mode when we fly our weather balloons because we're flying up to 100,000 feet in the air. We have to make sure that we're in high altitude aviation mode so that the chip knows that to expect that information. Otherwise, it would stop working and it would be very confused. So some GPSs, although we have GPS coverage globally, not every GPS device is created equally and is meant for specific purposes. So that is an important distinction. Is this what the scene would look like if aliens contacted NASA? Yeah, I'm sure the scene would be crazy. Let's see. Nope, been a while since I read it. 35 minutes of press conference. I think In that case, the building would be flooded with journalists. Yeah. Basically, the limit is there to prevent any GPS receiver from being used as part of a missile guidance system. Oh, yeah, that's true, too. Yeah, you can't... They also have... So GPS is also very controlled at... The GPS satellites have the capability to do very, very refined and precision measurements. But what they make available to people and to other countries and to companies is limited on purpose to prevent them from being used maliciously for things like missile guidance systems or covert and spying operations and things like that, military operations, all that kind of stuff. So let's see. Space Lobster strikes again. I like where your head's at, Michael. I like it. And with students right now, we're watching this together. Most of them didn't know what ULA even was until just now. Well, that's awesome. I'm glad to see that we got some students involved in learning about the whole process. It's too bad that this is we've got an anomaly and that this is not going well this morning. But where is it now? Should have passed over us again at 17. Yeah, we don't know what the orbit is. So they have not told us what the orbital parameters are. So we don't know. We don't know what the orbital period is. We have no idea. Yeah, and as Sebi Time Waster points out, a typical orbit for the International Space Station is once every 90 minutes. And we've been going, it launched 2 hours ago. So it could have already come around, but if it's in a big elliptical orbit, well, I guess it would be in a small elliptical orbit. There's no way it circularized or went past, or at least I don't think, that it went past the orbit of the International Space Station. So it should have made at least one revolution at this point. Maybe it landed. For all we know, it might be on the ground. We don't know. We've gone radio silent. So let's see. Flight controllers have performed a successful initial burn. Starliner is in a stable configuration, but next steps are being assessed. That's from Michael Baylor from Next Spaceflight. That's a little bit confusing. Emery Kelly's reports. Update from Boeing. Starliner experienced off-nominal insertion in a safe and stable configuration. Successful initial burn. Assessing the next steps. Still reviewing options for the test while the spacecraft is in orbit. Okay, so we had some sort of initial burn. Maybe it's just not the one that we wanted. And so it is in orbit. So that clarifies a few things that how we got into orbit. So we had a successful initial burn of some sort. Let's see. I just read that one. What else do we have? Got Scott Chapman. Was trying to see the closest approach. Says nothing seen. I'm assuming like from some telescope or something like this. This is Scott at Scott23192 on Twitter. Says nothing seen at coordinates pointing northwest to the general area of what the closest approach should have been. So it says it should have been. He was looking out for something there. Let's see. This is John Gardy, just a tinker on Twitter. Dragon was placed in a. I like that we've got. Dragon was placed in a much higher orbit that was stable. They had lots of time to troubleshoot. Starliner's orbit at SECO was 90 miles by 39. Okay, that was miles. I kept quoting it as kilometers, but it's miles. Here's where the ISS is right now. So re-entry will be along its plane. Not a lot of land to land on. All right, so that's interesting. Thanks, Space Gal, for sending that over to me. So here's what here's where we are. This was 20 minutes ago. Oh wait, you guys can't see it. Here, let's switch over. There we go. So this is this was 20 minutes ago. This is where the International Space Station was located up here. So it launched while it was down here, and it was supposed to do this kind of rendezvous with the International Space Station. Oh wait, here's the International Space Station. So this was 20 minutes ago. It was right here. So 20 minutes ago, the International Space Station was here. Now, Starliner is not lined up with where the International Space Station is, but it's along the same path. So Starliner should be traveling along this path, and potentially they could be looking at re-entry and trying to land on land here. I don't know. That would be kind of crazy. Because I don't like, where are you going to come down? Where you gonna, so he's going to come down in some farm field in Kansas somewhere or something. Like, I don't know. Kind of crazy. How would you like to be that farmer that goes out to check on your fields, or just hanging out outside, and all of a sudden you got a spacecraft coming down, parachuting down into your field? But yeah, and they could always come down in water too. It's not meant to come down in water, but it's capable of coming down in water, because that's what it would do in like a pad abort scenario. Let's see. All right, so we had a couple of other notifications here. Recap where we are. Off-normal insertion occurred. Will not say if it was Atlas or Starliner issue, but we had Emery Kelly from USA Today confirm that it was not an Atlas issue. Before orbit insertion burn, Starliner couldn't be placed in the correct attitude. Some kind of burn limped Starliner to orbit, and that looks like what we just saw a minute ago, which is that we had a successful initial burn, whatever that is. Yeah, so this doesn't really say much that we don't already know. Yeah, so the important thing is it's safe and stable, which is, yeah, I mean, that's cool, but we want to know what's happening with the mission. So I guess there's a press conference coming in half an hour. Oh, there we go. There you go. Boeing Starliner's flight controllers have completed an adjustment burn and are assessing the next steps. So it sounds like they're trying to save it. Did it save it? Adjustment burn? Maybe that's this initial burn that they're talking about. I'm very confused. This whole thing is very confusing. Wait, what? Why? I don't know why they're using different terminology in different places. Nowhere on here does it say anything about an adjustment burn. What is this adjustment burn? The only burn that they talk about is completed a successful initial burn. Wait, what is this initial burn? And what's the difference between initial burn and adjustment burn? I don't understand. I'm getting frustrated. It says successful initial burn. But we go back to here, Boeing Space Twitter account says flight controllers just completed an adjustment burn. What? What is happening? Why is this so hard to communicate effectively? I don't get this. This is getting me annoyed. Anyways, I just don't understand why it's so hard to just be like, hey, this is what's going on. I mean, unless they don't know what's going on, but I find that hard to believe. Like, it seems like they ought to know right away, especially at this point. Let's see. NASA knows everything there is to know. They just don't tell us. Yeah, that's kind of, yeah. We know where every plane is. They should publish a tracking of this object over our heads. Well, generally, like once you get into a stable orbit, or even one, if the spacecraft gets into an orbit that is, going to repeat over and over again, a lot of like sky watchers and astronomers and things like that can track these things down and locate and publish, like on the Heavens Above website or anything like that. They'll publish like where these things are located. But generally, it can be kind of complicated because you have to know what the orbit is, and that's either by what the company has published or by somebody tracking it. And right now, it just hasn't been up there long enough for anybody to track it. And obviously, the company is not publishing what the orbit is, so it's very difficult to be able to publish where it is. Let's see. Gregorius says no radio signals from Starliner were received from Europe either on 2232 megahertz during the low pass just now. It could have been too low for me, or it's no longer transmitting its frequency. What's that from, Gregorius? Let's see. This isn't NASA. It's Boeing. Well. Yeah, it's Boeing. Well, and it's looks like Sebi Time Waster kind of pointed out. It is a Boeing vehicle, but this is very much a NASA mission. Like NASA's calling the most of the shots here. Like they're in charge. They're in charge of this mission. They may not be operating the actual vehicle and the ones running the controls, but they very much call the shots in this. Let's see. From Sesbasa on Twitter. Oh, okay. Thank you, Gregorius. That's what that quote was from, the radio. J. King has 76 by 192, or 76 by 191 is the orbit. Where'd you get that, J. King? I haven't seen anything reliable that has any. Oh, actually, Space Gal just tweeted me something from Cosmic Penguin that has NORAD and the 18th Space Control Squadron, which detects and tracks pretty much all the objects that are in space, like we were talking about, and says currently showing one object in their TLE pipeline for the Starliner flight, which is in a 76 by 191 kilometer 51.6 degree orbit. Epoch is given at 11:59 UTC, so probably either Starliner or the Centaur immediately after separation. So we don't know if that's Starliner or Centaur. I would guess that's Starliner. Yeah, I'm guessing that's Starliner that is 76 by 191 kilometers, which is also what J. King said here as well. Yep, it says NORAD has it at 76 by 191 kilometers. And yeah, 76 is low. I mean, that's not sustainable for for many orbits. So that is that would that would not last very long unless they're able to create a burn. But I don't know what this adjustment burn is, or the initial burn, adjustment burn, whatever. I don't know. I'm annoyed by the lack of information here, especially since I gotta go. I was supposed to leave like 40 minutes ago, but I just don't want to. Not good, and astronauts are supposed to be in this. Well, the good news is about this whole thing is, if there were astronauts on board, everybody would be safe. And that's the good news in all of this, is there's nothing dangerous really happening. Everybody would be safe. Astronauts would be safe. They'd be able to come back. So that's it. What? All right. So Emery Kelly just tweeted out on Twitter. This is going to make me even more annoyed. So Emery Kelly is from Florida Today, which is run by USA Today. Emery Kelly says, okay, just kidding. There will not be a 9 a.m. press conference on OFT. But there will be apparently 2 conferences at some point, maybe today. What? This is crazy. All right. So I don't know. We're going to retweet that so people can see it. I don't understand the lack of information. Like, why can't we just come out and say tell us what's happened so far? We don't even have that. Luckily we got a lot of super sleuths on Twitter that have been able to figure it out, between people tracking down the NORAD orbital parameters, to Scott Manley looking at the breaking down the video, to Jonathan McDowell. We got all these people that are just kind of investigating. Like, why? I don't know why they just can't tell us what's happened. Boeing and NASA are working together to review options for the test and mission opportunities available while Starliner remains in orbit. So basically, they're trying to figure out if they could save the mission at this point. They don't know if they'll be able to save the mission, because 2 things to consider. One, do they have enough fuel and do they have an opportunity to be able to rendezvous with the International Space Station? So don't forget, the International Space Station is still in a completely different orbit, much higher orbit than Starliner is in. So that means that Starliner would be traveling faster than the International Space Station, is going to start getting away from the it's going to be increasing its distance from the International Space Station. And so they would have to make sure that those orbital planes, they can still line up at some point during their orbit. They'll probably have to burn more fuel than they planned on burning. So do they have enough fuel available to do it? And will they be able to do it in a timeline that's acceptable for I wanted to say Crew Dragon. It's not Crew Dragon, it's a Starliner capsule. Are they going to have enough fuel to be able to do this? And can they do it before they run out of time? Only meant to fly for 120 hours. So we don't know. We don't know what's going to happen. So let's see. Soul Rescue says thinks more people should like the video, and JQ just liked and subscribed. Well, thank you, JQ, and thank you, Soul, for pointing it out. But yeah, while you're here, make sure you follow along, subscribe, depending on where you are. Follow on Periscope or subscribe on YouTube, and either throw some hearts over or like the video, because that lets me know that there's people out there that like this kind of content, which I like, and otherwise it's just me sitting here talking to myself, which I would probably do anyways, but at least it lets me know that there's people out here that like this sort of stuff. So anyways, I do appreciate everybody hanging out here while we try to weed through the mess of confusion here. Let's see. Will you be scoping about this today? Probably. I guess it depends. It depends on what we know. I mean, right now I have no more information, so probably going to have to end this here, and we'll do maybe like a Periscope update a little bit later today. I don't know. All right, Donald Moreland just joined in, and he wants to know if we can fill him in on what's happening. All right, so we'll recap with what we know on what's happening here. Let me just see. I want to see if there's any more updates that I've missed. Okay, here you go. Chris, here we go. This is from Jim Bridenstine. Here, we'll go over here. Jim Bridenstine on Twitter. Update: Starliner had a mission elapsed time anomaly, causing the spacecraft to believe that it was in an orbital insertion burn when it was not. More information at 9 a.m. Eastern Time. Okay, so this is confusing. Emery Kelly just said they're not going to have a 9 a.m. press conference. Jim Bridenstine says there's more information coming at 9 a.m. Okay. I thought the 9 a.m. right here. Ryan Bale says, I thought the 9 a.m. press conference was canceled. We don't know what's going on. Nobody knows what's happening. This was 2 minutes ago, 8:45 a.m. Okay, so Starliner had a mission elapsed time anomaly. That could be a problem, especially from a software standpoint. Like if your software clock is not on the right time scale, then it's going to cause all kinds of issues, because the software is going to think it's at a different point in the mission than it actually is. So yeah, we had some sort of mission elapsed time anomaly. It's according to, that's Jim Bridenstine. That's a good source. He's the NASA administrator. So anyway, that was the new information. We can recap all of this because we've got such a mess of confusingness. Just don't. Very confused. Screenshot of Jim Bridenstine's tweet on the mission elapsed time anomaly that Starliner suffered. No briefing at night. So this is potential flight software issue. Presser in 15 minutes. So just me talking out loud. Yes. Okay. Very confused. So Emery Kelly is still kind of he's doubling down on the no press conference. No press conference at 9 a.m. So screenshot of Bridenstine's tweet on the mission elapsed time anomaly that Starliner suffered. No briefing at 9 a.m. though. Even though Jim Bridenstine just tweeted more information at 9 a.m. This is so confusing. I love and hate when stuff like this happens. I mean, it makes for a very interesting morning, but it's also very, very confusing. Let's see. And okay, so here's confirmation from Chris G at NASA Spaceflight. So the 9 a.m. press conference has been canceled. All we know now is that there will be 2 press conferences at some point. It's right there from Chris G on Twitter. So he's kind of backing up what Emery Kelly is saying about the press conference being canceled. Very confusing. All right, well, this is very confusing. So let's recap here for let's see. Let me check some comments here, and then we'll recap. Somebody's talking about Iran buying Boeing plane. I'm not going to get into any of that. You guys can talk about that in the comments if you want. Let's see. So Donald wanted to know if we could fill him in. Let's fill in Donald. Oh, wait, here you go. Gregorius just said there's a second set of orbital elements released just now. 187 by 222 kilometers. So, I mean, that would be much better. That's a much higher orbit. That's a stable orbit right there. 187 by 222. Almost circular. Let's see. So we sounds like a software or sensor problem. Okay, I gotta go. I'll check Twitter later. Yeah. So all right. So let's recap because I'm probably gonna have to wrap up here, and then we'll put more on Twitter later. So just in case you're not following now, I would definitely recommend go follow over on the Twitter machine. Because we'll have some more updates a little bit later, maybe do a Periscope a little bit later once we get some more updates. But here's what the problem is so far. So the Atlas V launched the Starliner capsule into orbit. Atlas V did exactly what it's supposed to do, dropped it off in a suborbital trajectory. Everything was fine from the Atlas V standpoint. ULA's mission done, complete, over with. Starliner then at that point had to go circular, had to circularize the orbit. In order to do that, it does an orbital insertion burn. That burn either did not happen or started happening and was pointed in the wrong direction. It's very fuzzy on exactly what happened, but it didn't get into the correct orbit. Something went wrong. According to Jim Bridenstine, what went wrong was a mission elapsed time anomaly. Basically, the spacecraft's clock was wrong. So the clock was wrong. It thought that it was at a different part of the mission than it actually was. And so it sounds like some sort of software, sounds like a software issue to me. But anyway, so they were not, the orbital insertion burn did not happen. They did perform an initial burn to get it into at least a very shallow elliptical orbit, so it stayed in space. It sounds like now, based on what we just saw with the NORAD tracking, that it's now in a much higher stable orbit, 187 by 222 kilometers. That's a stable orbit. Now the question is, which we don't know, we still don't know exactly what happened, and we don't know if they're going to be able to continue the mission. It sounds like they're going to be able to it sounds like they're going to try to continue. Of course they're going to try to continue, but it sounds like they're going to try to continue because they've got themselves into a much higher orbit and they want to try to get to the International Space Station. They're going to have to burn extra fuel to do that, and the Starliner crew capsule is only meant to fly free for 120 hours. So they have to make sure they can get to the International Space Station with a little bit of time to spare, so that they can be prepared and also have time to come home at the end of the mission as well. But yeah, they're evaluating that on whether or not they're going to be able to continue. So that's pretty much where we are right now. NASA and Boeing kind of went radio silent for a while, but it was very confusing. So, all right, we got another tweet from Jim Bridenstine. Says, let's see, we'll pull it up on the screen here again. Says, because Starliner believed it was in an orbital insertion burn, or that the burn was complete, the dead bands were reduced and the spacecraft burned more fuel than anticipated to maintain precise control. This precluded Space Station rendezvous. We are getting good burns and are elevating the orbit of the spacecraft. Okay, so they are elevating the orbit, bringing it up to the same, basically trying to catch up to the International Space Station. But yeah, so basically what he had said earlier right here. So, Starliner suffered a mission elapsed time anomaly, caused the spacecraft to believe it was in an orbit insertion burn when it was not. So basically the clock was wrong and the spacecraft thought that it was either in an orbital insertion burn or that the burn was already completed. And so it was basically like, we don't need to do a burn anymore because that was supposed to happen at this time, and they missed it. So, all right. So that's where we are. That's what we know. Not much more. Let's see. Updates are just streaming in. Getting the best updates from NASA admin Jim Bridenstine right now. Presser at 9:15. Okay, now they're saying the presser's at 9:15. I'm very confused. Yeah, so Jim Bridenstine luckily has given us a whole lot of useful information. So it's a little more cool. All right, here's another tweet from Emery Kelly. A little more clear. This is why Starliner didn't make it to the ISS. According to NASA administrator, Starliner had a mission elapsed time anomaly. Yeah, this is basically what we just read on Twitter. So that's what we know right now. Mission elapsed time anomaly, and sounds like they're still going to proceed on with the mission. Hopefully they can still get to the International Space Station and they can accomplish at least the goals and the demonstrations that they need to accomplish for this mission, so they don't have to do a complete redo. All right. Well, did we miss anything? Because I'm going to have to wrap up. I mean, I got to work today. I got real work I got to go to today. Are you an astronaut? No, I'm not an astronaut. I'm a software engineer, and I have to go do some software engineering here. Let's see. Even if it does not burn at all, the capsule is so... Oh, they're talking about burning up on re-entry. Yeah, I don't think that would be... I'm not too worried about that. Yeah, they could bring it home. That wouldn't be a problem. But it sounds like they're raising the orbit. They're going to try to save this mission. Let's see. Yeah, no one knows anything business as usual. Yeah, the updates are coming in very sporadically. NASA TV is saying press conference is next. It does say the press conference is next, which is interesting. This is NASA TV post-launch news conference next from the Kennedy Space Center. Wonder if anybody shows up to this. Because from what I've heard from Chris G. from NASA Spaceflight, Emery Kelly from USA Today, this press conference is canceled. This Gregorius says press conference is now expected for 9:15 on NASA TV. NASA said no ISS. Where'd you see that, Jay King? No ISS, because I didn't see that anywhere. I did. It sounded like, according to Jim Bridenstine, that they were going to sounds like they're raising their orbit and still going to try for it. But naturally, you might be concerned if you got attitude control problem concerns. You might be concerned about whether you want this thing to approach the International Space Station with whatever this anomaly is. And I wonder, back this thing up, go whole full circle back to the launch broadcast, rewind almost 3 hours ago, almost 4 hours ago. They had some sort of anomaly this morning, which they didn't specify, or at least I didn't hear them specify it, that they had some sort of an anomaly that they were working through, and they didn't really say whether they resolved it or not, but they were like, we're confident that we can do the flight anyways. I wonder if that had something to do with the mission elapsed time clock. So that's a big question. JQ says he's a new subscriber, but he doesn't know my name. Well, that's a good opportunity to let people know where you are and what we're hanging out doing. So I suppose I could throw up, we could throw this up here so that at least you know who I am and what we're doing here. we're trying to figure out what's happening with Orbital Flight Test here for Boeing. But it's been quite a confusing morning. And we're trying to figure it out. I don't know if I can stay for the press conference. I really have to go. I was supposed to go like an hour ago. Let's see. Have they tried to turn it off and turn it on again? That's always my first recommendation. Turn it off, turn it back on again. That'd be what I would tell them to do. Let's see. Okay, so now Jim Bridenstine says the information coming in is just all over the map. So we had 9 o'clock, then we had 9:15, and now we're at 9:30. Moving news conference to 9:30 a.m. Eastern time. I definitely can't make 9:30. So I'm probably going to wrap it up here. And then we're gonna try to keep an eye on this and throw some stuff out on Twitter a little bit later. So I guess make sure you head over to the Twitter machine. I mean, if you don't follow me, at least follow somebody, because Twitter is alive. It is going nuts right now. And you should also, I would also say, definitely subscribe to the YouTube channel too if you're here, the YouTube. So, or if you're on Periscope, we are simulcasting on Periscope and on Facebook as well. So, subscribe whatever platform you like better. We usually do these on all of them, but I might do a Periscope a little bit later today. So, the Twitter and the Periscope might be a good thing, because that I can do right from my phone a little bit later today, and because I won't be by my computer later today. But Space Coast Beach Bum says Jim as docking's not happening. Sure miss seeing your stream. I'm assuming you're talking to me, Trippin' Fool. Reboot. Yeah. Yeah, we've got some craziness going on this morning here. So yeah, to recap, Atlas V successful launch. Starliner had a bit of an issue. It's in the wrong orbit. So we don't know what's going to happen. We don't know how this is going to we don't know how this is going to end up, whether it's going to come back. He did say, and by he, I mean Jim Bridenstine. Let's see, Boeing's press conference expected at 9:30, pending the arrival of participants. Interesting. I wonder who the participants are that are not on site already. So where's Jim Bridenstine's thing? He did say, I want to get this. Okay, because Starliner believed it was an orbital insertion burn, or that the burn was already completed, the dead bands were reduced and the spacecraft burned more fuel than anticipated to maintain precise control. This precluded space station rendezvous. So, I mean, essentially that means that this prevented space station rendezvous, or made space station rendezvous impossible. But it's still a little bit confusing. Like, does that mean like okay, this event made the initial rendezvous impossible, but we can try again later. Like we'll be able to try a different rendezvous. I don't, there's a little bit of ambiguity, I think, in that statement. A little bit confusing. So, let's see. I like Sean CLV on Periscope says, I'm picturing a clock on board the Starliner just blinking at 12 o'clock like on a VCR or a microwave or something. I like that. Wouldn't it be funny? It was just like flashing and then you're like, set clock, set clock. I don't think that's what's happening, but it would be funny. Make for a good comedy. Not that we want comedy for this, but when things are confusing, that's what we go with. Heard NASA said the orbit is stabilized, but last set of burns didn't fire for insertion behind the ISS. Yeah, so they have raised the orbit. Right now we're in an orbit, according to the NORAD tracking, the orbit, was it 187 by 222 kilometers? I think, 187 by 222 kilometers. So that's a relatively high orbit. That's a stable orbit. That would stay in orbit for a while. The question now is going to be, are they going to rendezvous with the International Space Station? Is that out? Like, are they too far away with not enough fuel so they won't be able to get to the International Space Station? It could be they might not be able to get to the International Space Station. So will they be able to get there? Will NASA still allow them to dock? And will they have enough battery power and flight time, because it can only fly for 120 hours by itself? Will it have enough flight time to get to the International Space Station and be able to come home? Or are they just going to have to skip the whole ISS visit and come straight home and turn this car around? If this thing crashes into a city, they'll wish they could have blown it up. Well, I don't think that's going to happen. Especially the fact that it's in a stable orbit. I mean, 187 by 222, that's a stable orbit, meaning right now it'll just orbit forever, or mostly forever. I mean, a tiny little bit of atmospheric drag, but not enough. I mean, that'll be up there for years unless somebody does something. So pretty much Boeing can control exactly where it's going to come down at this point. So I wouldn't be too worried about it crashing into a city. The only way it's coming down is if Boeing tells it to come down, and they'll be able to tell it where to come down. So, and at this point, they're going to be manual commands anyways, because they're off the mission timeline. So anything that they tell the spacecraft is going to be completely manual. And so this mission elapsed time anomaly is not really going to be an issue, because they're just going to tell the spacecraft what to do, and instead of it doing it on its own, ground controllers are going to be telling it what to do. Trip and Fool, any type of precious cargo in it? It's not really like precious cargo. There is about 270 kilograms of supplies for the International Space Station. There'll be like food and random, little supplies for the space station that they may not get, but it's not really a big deal. They've got plenty of food and stuff like that. This is just extra supplies. We've got the anthropomorphic test dummy and our zero-G indicator. Snoopy and Rosie is the ATD, anthropomorphic test dummy or test device, whichever you prefer. Let's see. No Christmas presents for the astronauts on the space station. Yeah, right. Yeah, so that's where we stand right now. I'm going to wrap up because I really have to go. I was supposed to leave like an hour and 10 minutes ago, but I'm going to wrap things up and head out. So make sure you follow along and follow the conversation on Twitter, because things are happening. A lot of stuff happening. There's a press conference coming up on NASA TV at 9:30. Just kind of chilling here right now. So you can watch NASA TV on YouTube or watch NASA TV directly, whichever you prefer. But it's coming up soon. I'm not going to be able to stick around to watch it, but it is coming up. And so you guys can check that out, and I will tweet out updates a little bit later for sure. So yeah, just make sure you follow the conversation over on Twitter, and we'll figure out what's going to happen here, and whether we're going to the space station or it's coming home, and we'll see. Don't know. Interesting. Not how I thought this morning was going to go, but that's a little bit unfortunate. Probably going to cause some sort of delay for commercial crew. I'm sure somebody at SpaceX probably a little bit relieved about that, considering the two of them are racing against the clock to see who's going to be first. But SpaceX has still got their own in-flight abort test that they still have to do before they can put crew on board. So the saga continues. A little more delays probably for Boeing, and we'll see if they're going to recover this mission, or they're going to need a redo, because we don't know. So, all right, that's going to be it. I really do have to go. It's been an interesting morning here so far, but I got to get to work. I got stuff I got to do, and I'll tweet some more updates out a little bit later. But thanks everybody for joining in. It's been a 3-hour broadcast. This was a long one, but I do appreciate everybody hanging out for today. And we'll be everybody have a good holiday, because I won't be live. I might be live on Periscope later. Maybe. It's not 100% sure on that. But if I don't see you on Periscope later, then have a happy holiday. Whatever you're doing over the holiday season, enjoy it. And we'll be back for what is the next thing that we'll be back for? I think the next thing we'll be back live for is going to be in-flight abort for SpaceX, right? That's January 11th. I don't think there's anything between now and then, unless we have something big with Starliner, or maybe Periscope stream a little bit later. I don't know. We'll see. So, all right. Happy holidays, everybody. Thanks for joining along. My name's Tori. This is Overlook Horizon, and we'll see you guys all next year, probably in the new year. So we'll see you next year. Thanks, guys. Have a good day. Goodbye.